SABCS, we are able to educate our patients. We're able to bring advocates to us and have them tell us what they want and what they need from us, but also is able to bring researchers together to start the conversations that we need to have for our new clinical trials.
I think the symposium helped to bring together all the people around the world that do breast cancer research, from Europe to Asia. And I think that's made a major impact. I have many friends now throughout the world because of this symposium. I think it also spawned some similar meetings now ongoing in Europe and other places to spread the word about breast cancer research and the accomplishments that we made. So I think it's had a major impact across the global spectrum.
I think that we also will be doing way more research on breast cancer health disparities. For the last several years, I think we have not paid enough attention to breast cancer health disparities, and I think there's going to be an increasing impetus and emphasis to focus on that.
I think that clinical trials are vital. I think that anything that I can do to help researchers further the work that they are doing is important.
As an advocate, my message to scientists and researchers is to continue to involve patients in early development of their clinical trials and to also include the diversity of these patients.
But just knowing that there is something that I can do, not only for myself and for my family, but for the broader breast cancer community is so rewarding. It has afforded me a seat at the table. But not just a seat at the table, to be in community at that table through sharing, which benefits all. It benefits the patients, the clinicians, and the researchers. And that has been so very important to me.
I mean, totally invaluable when they all come together and congregate and they share knowledge and they disseminate knowledge. I don't know how they could do it without these kinds of meetings. It was exceptional. There's nothing that can replace it, in my opinion.
A cure would be a wonderful thing. It would be something that would be unbelievable. But anybody that's metastatic, sure, we would love a cure. But what we really want is to stop progression. It's as good as gold for us.
Good morning, San Antonio. My name is Virginia Kaklamani. I'm from UT Health in San Antonio, and I want to welcome everybody today to the 47th San Antonio Breast Cancer Symposium. SABCS has grown substantially. This year, we have the highest attendance we've ever had, but we also have had the highest number of submitted abstracts. The strength of the meeting lies in its multidisciplinary as well as translational scope. We have cutting-edge research presented, and we have clinical trials that lead to drug approvals being presented every year at SABCS. Last year, the INAVO120 trial was presented here, and it led to the approval of inavolisib just a few weeks ago by the FDA. This year is no exception. We have several pivotal clinical trials being presented, and the late entry, just as of 2 days ago, the PATINA trial will be presented here tomorrow. This is a trial which is a phase 3 clinical trial looking at the role of CDK4/6 inhibitors in triple-positive breast cancer. Dr. Arteaga and I were invited to write an editorial on the breast cancer statistics of 2024. Several important themes arose from that paper. First of all, the incidence of breast cancer is increasing, mostly in young people. Also, women of Asian American and Pacific Islander heritage have a higher incidence of breast cancer compared to other racial groups. However, mortality rates are down. although Black women still have higher mortality rates from breast cancer compared to white women. So how do we find a cure? And we think that the fastest way to a cure is by risk reduction and early detection. So for this reason, we have included 4 sessions on risk reduction and early detection on the program this year. We're looking at obesity and its role in breast cancer screening, the future of cancer genetics, as well as new directions in breast cancer prevention. Now, if you missed the obesity session yesterday evening, please go back and watch it virtually. It was absolutely outstanding. Another area which is taking over our daily practice is artificial intelligence. As our phones are listening to every word we say, and computer algorithms know what we want before we even do, it was just imperative that we included artificial intelligence sessions to the meeting this year. So we're going to have 2 sessions, one looking at diagnosis and discovery with artificial intelligence, and the second one looking at AI in clinic. So please don't miss those sessions. Now, our debate this year is focusing on universal germline genetic testing, and the people's choice is on another topic that's been of huge interest in the past several years, antibody-drug conjugates. Now, I'd like to introduce the newly elected member of the National Academy of Medicine and the Simmons Cancer Center director at UT Southwestern, my co-director, Dr. Carlos Arteaga.
Thank you. Thank you, Virginia. Sorry for the raspy voice. I think this year, like in past years, the SABCS will host 3 major awards. The Maguire Award, which will go to Laura Van Veer from the University of California in San Francisco. The AACR Distinguished Lectureship in Cancer Research that will go to Steffi Ostrich from the University of Pittsburgh Medical Center, and the AACR Outstanding Investigator Award for Breast Cancer Research that will go to Christina Curtis at Stanford University. This meeting has happened because of the effort of many. Thank you to the Program Committee, to the Abstracts Review Committee, to the Clinical Trials Committee, the Maguire Award Committee, the AACR Award Committees, all our supporters and exhibitors, and the University of Texas and AACR staffs. And special thanks to our San Antonio Breast Cancer Symposium Program Coordinator, Kate Lathrop. This year, we'll have a special opening keynote lecture that will be delivered by Dr. William Kaelin. Dr. Kaelin received his MD degree from Duke University in 1982 and was a house officer and chief resident in internal medicine at Johns Hopkins Hospital. He trained in medical oncology at the Dana-Farber Cancer Institute and was a postdoctoral research fellow in the laboratory of Dr. David Livingstone, where he began his studies on tumor suppressor genes. He joined Dana-Farber in 1992 as an independent investigator, and as of 2002, he is a Howard Hughes Medical Institute investigator and professor of medicine at Harvard Medical School. The 2019 Nobel Prize in Medicine and Physiology was awarded to Dr. Kaelin together with Sir Peter Ratcliffe and Greg Semenza for their discoveries of how cells sense and adapt to oxygen availability. The topic of Dr. Kaelin's talk is very aligned with the progress we have made in breast cancer, where we have discovered many therapeutic targets and developed drugs that are continue to improve the outcome of patients that we serve. The title of his talk is Reemerging Principles for Controlling Cancer with Drugs. Dr. Kaelin, please join me at the podium.
Well, thank you very much. It's a pleasure to be here. I've heard about this meeting for decades, but this is actually my first time I've had the privilege of attending, so thank you very much. So hopefully you can all see my disclosure slide at this point. I think that's considered appropriate. So I'm always looking for new examples that I can use to illustrate to students the danger of confusing correlation with causation. So for example, this is the performance of Lilly Pharmaceuticals. I joined the board of directors of Lilly in 2012, so that's a nice correlation. And if you're feeling particularly generous and kind this morning, you might even imagine ways that this could be causal. But I always remind the students that correlation, even when you have plausibility on your side, is not the same as proof of causation. So the correct answer here, of course, is that this was an uncontrolled experiment, and for all anyone knows, maybe Lilly would have done twice as well had I not been on the board. Now, the reason I point this out is, now let's go a little bit closer to the world we live in. So I look at countless papers nominating new cancer drug targets where somewhere in the paper there's a Kaplan-Meier curve that looks something like this. And the authors will point out that the expression of their favorite gene is associated with a bad prognosis and therefore argue that this would be a good target in cancer. But of course, this is a fallacious argument. And to see this very clearly, here's a fictitious set of another Kaplan-Meier curve. Let's imagine people with chronic lung disease who ever have been or not have been on a ventilator. You can be sure that people with chronic lung disease who have needed a ventilator at some point or another have a worse outcome. But I hope the response wouldn't be to say, let's remove all the ventilators from the ICUs. Of course, this is simply a prognostic marker. It's not necessarily helping us with respect to choosing therapeutic targets. Now, you laugh at that one, but here's one closer to my world of HIF and oxygen. So I can tell you there are hundreds of papers that have been published that show that intratumoral hypoxia and upregulation of the HIF transcription factor is associated with a bad prognosis. And a number of people have used this as one line of support to think maybe we should be developing HIF-1 inhibitors, for example. But again, these people are confusing correlation with causation. It's certainly possible that hypoxia upregulates the HIF transcription factor and that HIF somehow causes aggressive tumor growth. But I would say it's even more likely that aggressive tumors outgrow their blood supply, become hypoxic, and thereby upregulate HIF. And of course, you can come up with more complicated scenarios as well. Maybe hypoxia does induce aggressive behavior, and it also upregulates HIF, but it's true and unrelated. And of course, you have to understand that which of these scenarios is correct in a given cancer if you're going to make the commitment to develop a HIF inhibitor. So if being associated with a bad prognosis doesn't rule you in as a good cancer drug target, how about being associated with a good prognosis? Does that rule you out? And I can tell you, you may be aware that a subset of gliomas have mutations in IDH1 or 2, and in fact, these mutations are associated with a good prognosis as brain tumors go. And I heard professorial level people say that it would be unethical to treat people with IDH mutant glioma with IDH inhibitors because it's associated with a good prognosis. But of course, based on that logic, this group never would have targeted the estrogen receptor in breast cancer. So the take home for this segment of the talk is that being associated with a poor prognosis is neither necessary nor sufficient for being a good cancer target. So where should we look for cancer targets? Well, one of the advantages of being on the Lilly board is I get to scan different therapeutic areas, not just cancer, and I can see which ones are making lots of progress and which ones are making very little progress. And what's very clear is the following. So the therapeutic areas that are making lots of progress have an abundant number of genetically validated targets where the biological and biochemical functions of those targets is pretty well understood. So for example, autoimmune diseases are up here. That's one of the reasons you see all these annoying ads for drugs for dermatitis and inflammatory bowel disease and psoriasis, et cetera. At the other extreme are the psychiatric diseases where sadly we've made very little progress since the Eisenhower administration. The really only big advance in the last decade arguably has been the use of ketamine for depression, and that was discovered through serendipity. Now, this importance of having genetics on your side has been quantified by a number of groups that have looked at success or failure in drug development programs in pharma, and they come to the conclusion that having genetics on your side at least doubles your chance of success when you're developing a new drug. And that's because genetics is an incredibly powerful tool for establishing causality. You know a particular gene, when altered, produces some phenotype, produces some disease, or produces some outcome that you'd like to mimic with a pharmacological agent. So my view is that studying cancer without genetics on your side is sort of like the old story of the blind man and the elephant. So you can do all the omics you want. You can do transcriptomics, proteomics, metabolomics. But if you don't have genetics on your side to establish causality, you're basically doing the molecular equivalent of the blind man and the elephant. Now, fortunately, genetic validation can take multiple forms. It can take the form of germline human variants or mutations. It can take the form of recurrent somatic mutations in particular cancers. It can take the form of properly controlled somatic knockout or knockdown studies using tools such as short hairpin RNAs or now CRISPR. And it can also take the form of mouse knockout studies. Now, I emphasize in red properly controlled because I would argue the early adoption of these somatic knockout and knockdown technologies without proper controls was one of the things that led to a problem in the literature, which is our colleagues in industry tell us that 50 to 80% of the time when they go to replicate findings related to new cancer targets, they either can't reproduce them at all or they're not robust, meaning that they're only true under very narrow conditions. So we have to do better and apply the appropriate controls. I'll come back to that later. So if you look at cancer drug approvals, here I've chosen at random maybe some of the drugs that have been drug targets that have led to approvals in the last decade or so. And you can see, as I would have suspected, that most of them are in the upper right quadrant. These are genetically validated targets where we knew something about their biological function. So for every 10 or 20 of these, there's maybe one drug at the lower left that also was approved. So here, as you may know, we use proteasome inhibitors to treat multiple myeloma, but there never was any genetic evidence in support of that target in multiple myeloma. And even now, there are only post-hoc arguments for why proteasome inhibitors work so well in multiple myeloma. That was relying on basically serendipity in the early clinical development of these drugs. Now, some of you might be surprised to see that the immune checkpoint inhibitor targets are also in this upper right quadrant, but they were genetically validated using mouse studies. So, for example, in the case of CTLA-4, it was very clear if you knocked out CTLA-4 in the mouse, the mice developed autoimmunity. That this was effectively a rheostat on the immune system. And so the leap that Jim Allison and others then made was, okay, if you could then play with this rheostat, maybe you could amp up the immune response and this would be useful in cancer. How about angiogenesis inhibitors? Well, I'm old enough to remember when the New York Times proclaimed that Judah Folkman was going to cure cancer with angiogenesis inhibitors such as endostatin and angiostatin. But the targets for these quote-unquote drugs was never known. Their mechanism of action was not known, and hence there was no genetic validation for them. And of course, they failed miserably in the clinic. But fortunately, later on, the VEGF inhibitors appeared, where we had genetic evidence that VEGF was required for angiogenesis, and we knew something about how VEGF engaged this receptor and signaled to endothelial cells. Now, before going further, I want to address something I hear in certain corners of certain rooms, which is, really, in the end of the day, this is just too complicated. The cancer cells have too many mutations, and we'll never be able to fix all of them. So I think a number of people, if they don't say it out loud, they fear this, at least privately. But I think these people are confused about the difference between necessity and sufficiency. I actually think it's a very good thing that most common cancers, including breast cancers, require multiple driver mutations, that multiple driver mutations are necessary. And to see why that's the case, I like to use the analogy of a combination lock. So here I'm showing you a tumbler lock that has 3 tumblers. And if I asked you how many of the tumblers had to be in the correct position to open the lock, you would say, of course, 3. But if I now asked you how many of the tumblers had to be out of place to keep the lock from opening, I hope you would say 1. So here's a situation where 3 steps are necessary for the lock to open, and therefore undoing any one of them is sufficient to prevent the lock from opening. Now, I would even formalize this further and say that some of the mutations that occurred late during tumor evolution, whether they're driver mutations or passenger mutations, are only tolerated because of the mutations that preceded them. And if that's the case, then correcting early mutations should selectively kill tumor cells. The other reason for focusing on the early mutations is it also helps deal with another problem in cancer therapeutics, which is intratumoral heterogeneity. So I think you probably know from the work of many investigators, including, for example, the work of Charlie Swanton and colleagues, that if you take tumors and do multiple spatially distinct biopsies and do deep sequencing and calculate the mutant allele frequencies, you can then infer the evolutionary histories of those tumors. And so here's an example from a kidney cancer where you can see the initiating event was loss of the VHL tumor suppressor gene, and that was a clonal event. But then you can see some of these late cooperating mutations which occurred in a subclonal or branching fashion. And I would argue, based on first principles, if you're going to develop a therapeutic, you want to target something that's shared by all of the progeny and not just a subset. And so this has led to the idea of so-called truncal mutations as well as branch mutations. So I think this paradigm of targeting early mutations has been borne out well. Now, in the clinic, here's a very partial list of early mutations, or at least mutations that are suspected of being early mutations, where we've been able to treat them with small molecule drugs or with antibody therapeutics. But that leads to the next problem, which is there's no shortage of genetically validated targets in cancer that are deemed undruggable. Think about MYC, for example, or think about RAS, although there's been some exciting progress on RAS in the past year or so. So how are we going to drug these so-called undruggable but genetically validated drivers? Well, one approach would be to target downstream effectors, exploiting epistatic relationships. Another would be to look for allosteric regulators, allosteric inhibitors. There's renewed interest in this. I've had a long-standing interest in exploiting synthetic lethal interactions, and more recently there's been an intense interest in developing degraders. So with respect to the first two strategies, my lab's had a long-standing interest in the von Hippel-Lindau tumor suppressor protein, which is mutated and inactivated in a large proportion of kidney cancers, and this leads to the upregulation of the HIF transcription factor. So that's the correlation, but someone had to do the work to establish that HIF was actually causal here, that it really was all about HIF. And so many years ago, our lab showed that if you restore the function of the VHL protein in a VHL defective renal carcinoma cell line, they lose the ability to form tumors. And then Keiichi Kondo took these cells and introduced a form of HIF alpha, and in particular HIF2 alpha, that can't be recognized by VHL because of a point mutation in the VHL binding site. And now these cells regain the ability to form tumors. And in a complementary set of experiments, he eliminated HIF2 alpha with short hairpin RNA technology, although we've more recently done this with CRISPR, and that was sufficient to prevent these cells from forming tumors, at least in nude mice. So that really began to say this is about HIF, and in particular, it's about HIF2. And not shown here is when we did the same experiments with the more famous member of the family, HIF1, we got the opposite effect. So really, it was necessary to do these experiments to establish which HIF was causal here. Now, not shown here are the various controls I think you want to do if you're going to do these target validation or target credentialing experiments. And so here's a paper I wrote where I tried to summarize some of the things that I think have led to that problem of investigators telling us that 50 to 80% of the time they can't reproduce the findings coming out of academia. Now, what can we do about this therapeutically? Well, it was certainly known by the 90s that amongst the genes regulated by HIF is the famous VEGF angiogenesis factor. And so it turned out, for a number of reasons, pharmaceutical companies by the 90s were making inhibitors against VEGF, and we argued that if such VEGF inhibitors were going to work in any solid tumor, they should work in kidney cancer because of this intimate link between loss of VHL, upregulation in HIF, and regulation of VEGF. And just to see some evidence of this special relationship, here are data from Genentech, where on the y-axis we're looking at a measure of VEGF production, and along the x-axis we have the names of various tissues, and the green dots are the VEGF levels in the normal tissues, and the red dots are the VEGF levels in the tumors arising from those tissues. And so you can see that in many of these solid tumors, VEGF is modestly elevated, and that's as expected because most solid tumors contain regions that are hypoxic. But the 800-pound gorilla is clearly kidney cancer, where the VEGF levels go through the roof. And again, this makes sense because we know an early event is loss of VHL, upregulation of HIF, upregulation of VEGF, and at that point you probably remove the selection pressure to turn on other collateral alternative angiogenic factors. And that probably explains why I think we're up to 8 VEGF inhibitors that are approved in kidney cancer, including small molecules against the VEGF receptor and the antibody bevacizumab against VEGF itself. So that's the good news, but not every patient with kidney cancer will respond to these drugs, and even those that do will eventually progress. So how could we do better? Well, you might argue, just based again on first principles, that rather than targeting any one HIF responsive gene, we should target HIF itself, and again, based on our data, we should target specifically HIF2. But the conventional wisdom for many years was that HIF was undruggable, that it was a DNA-binding sequence-specific transcription factor, and it was thought to lack the same kind of ligand-binding pockets that you might see in, for example, the steroid hormone receptors. But I always remind students, beware of naysayers, and so this was a case where two very talented scientists who were then at UT Southwestern, Rick Brook and Kevin Gardner, ignored the naysayers, and they identified a potentially druggable pocket in the so-called PAS-B domain of HIF-2 alpha, and they then did high-throughput screens at UT Southwestern and identified chemicals that could bind to this pocket, and in so doing, induce an allosteric change in HIF-2 alpha such that it could no longer bind to its partner protein and hence no longer bind to DNA. Now, these chemicals were then out-licensed to a biotech company called Peloton that was subsequently acquired by Merck, and the chemist at Peloton improved the drug-like properties of these chemicals substantially. And so our lab and the lab of my former postdoc, Jim Brueggerolles, showed that a tool compound HIF-2 inhibitor did everything you would want in preclinical models of kidney cancer. It was highly effective, and also we could show that the effects were specific and on target. Now, just to show you an example of what I mean by adding the additional control, here's a classical soft agar assay that we did in my lab with a renal carcinoma cell line that was VHL defective, and where we treated the cells with this tool compound that inhibits HIF-2 at 0.2 or 2 micromolar, and you see virtual loss of soft agar growth. And so you want to say eureka, high five, but I point out this is the kind of experiment that gives cancer pharmacology and cancer biology a bad name, because I could do this with Clorox bleach, I could do this with formalin, none of that would be very interesting. And to make matters worse, I can tell you that at 10 to 20 micromolar, this drug or compound inhibits every cancer cell line we've ever looked at, including those that don't express HIF-2. So by definition, above 10 micromolar, that's all off target. So how would you know this is specific and on target? Well, the way to do that, that Chin Cho at my lab did, was she used CRISPR to actually generate isogenic cells that were identical, except they had either wild-type HIF-2 alpha, or they had a HIF-2 alpha variant where there was a point mutation in that PAS-B domain that prevented the drug from entering the pocket, but otherwise left HIF-2 alpha intact. And so now you can see this drug-resistant version of HIF-2 alpha now allows these cells to form soft agar colonies. Now, eventually, an improved version of this compound called belzutifan went into phase 2 trials for patients with advanced kidney cancer who had failed standard of care agents such as VEGF inhibitors and immune checkpoint blockade. And these, of course, are so-called swimmer's plots, each horizontal bar being a patient on the trial. For orientation, here's 1 year on therapy at the time of this analysis. And again, I will point out these were heavily pretreated patients, but all the patients with black arrows were doing well on therapy at the time of this analysis, and all the yellow star patients had a RECIST partial response, and I may come back to this trial towards the end. Now, I also mentioned exploiting synthetic lethality, so I've had a longstanding interest in synthetic lethality. I think you know that 2 genes are synthetically lethal if mutation in either gene alone is compatible with viability, but mutations in both genes simultaneously leads to death. And it was really Steve Friend and Lee Hartwell many years ago who told us we should really be applying this paradigm more frequently to cancer. And I don't have to tell this audience that perhaps one of the most spectacular examples of this in the clinic has been the use of PARP inhibitors for patients who have tumors with BRCA1 or BRCA2 mutations. So that's the good news. But frankly, with the availability of CRISPR and short hairpin RNA technology, I thought we were rapidly going to identify additional synthetic lethal interactors that we might exploit in cancer, but that hasn't been the case over the past decade or so. And I think one of the reasons for that is that many important genes in the mammalian genome have been duplicated. In fact, not infrequently, they've been triplicated. So now if you use a genetic tool to inactivate one gene at a time, here, for example, the B1, the B2, or the B3 gene, you're not going to see the synthetic lethality. You'd only see the synthetic lethality if you knocked out all 3 of the closely related paralogs. So I think we have to go back to the drawing board a little bit, and excuse me, my allergies are bothering me. I think there are lots of reasons for false negatives in genetic synthetic lethal screens, at least as they've been performed in the past decade or so. And so I think we have to be a little bit smarter. So I think the approaches that we and others are using are to use combinatorial CRISPR libraries that have been designed to simultaneously inactivate multiple paralogs. We sometimes perform screens in simpler organisms such as Drosophila, taking advantage of the fact that many important genes that have been triplicated or duplicated in the mammalian genome are actually represented as a single ancestral gene. in, for example, flies. And then we like to complement our genetic screens with chemical screens, leveraging the fact that many chemicals will interact with multiple related paralogs. Now, there are a couple other special cases of synthetic lethality that I want to discuss. We imagine that many cancers have increased oncogenic signals. Pick MYC, pick E2F, pick your favorite. And so the knee-jerk response is usually to then say, well, let's just develop an inhibitor of that oncogenic signal. And that certainly has served us well. But I think there's renewed interest on occasion to saying to the cancer, okay, if you want this oncogene, we're going to give you so much of this oncogenic activity, you're going to die. And this goes back to earlier observations in the 80s and 90s, where it was clear that with respect to oncogenic transcription factors such as MYC or E2F, cancers were already kind of running in the red zone, and if you could just artificially superactivate those oncogenic signals, the cells would undergo apoptosis. So last on the list is searching for degraders. So our lab and Ben Eber's lab showed several years ago that the thalidomide-like drugs, which of course have become mainstays of treatment in multiple myeloma, actually work by reprogramming a ubiquitin ligase that has at its core the protein cereblon. So these thalidomide-like drugs, once bound to this ubiquitin ligase, reprogram the ubiquitin ligase to now target for destruction two otherwise undruggable transcription factors called IKZF1 and IKZF3, which are near and dear to the hearts of multiple myeloma cells. Shortly thereafter, people like Jay Bradner and Craig Cruz showed that you could actually then re-engineer a thalidomide-like drug to engage a different target. And in fairness, this harkens back to earlier work by Craig Cruz and Ray Deshays, where they imagined bifunctional small molecules that would recruit an E3 ligase to target an undruggable protein. And so just to keep you up to date with the nomenclature, the IMiD-like drugs are now referred to as molecular glues. They're often much more drug-like than the much bigger so-called PROTACs. And this has led to an explosion in interest in developing small molecule degraders for undruggable proteins. This is a now up-to-date list of some of the biotech companies that have been created in this space in the past couple of years. Now, I would be remiss if I didn't show you this slide, which is arguably one of the most famous slides in all of clinical oncology, because you may recognize immediately that this is a patient who had multiple myeloma with a BRAF mutation. They were treated with a wonderful BRAF inhibitor developed by Plexicon and had this near complete remission. But then within months, they were right back in hot water. And this has led to a lot of hand-wringing in both the lay press and the scientific press as to whether targeted therapy is really all it's cut out to be. And here's an editorial written by the famous Jim Watson, who's still pretty influential in certain corners, where he says that given the seemingly almost intrinsic genetic instability of many late-stage cancers, we should not be surprised when key old-timers in cancer genetics doubt being able to truly cure most victims of widespread metastatic disease. Now, unfortunately for Jim, he didn't have the benefit that I had, which is that I was taught by the great Tom Fry when I was a clinical oncology fellow at the Dana-Farber back in the days of the dinosaur. And people like Tom Fry would teach you the principles of combination chemotherapy. So, of course, this audience probably knows that a cubic centimeter tumor could have 10 to the 8th, 10 to the 9th cells. The tumor burden in most patients is closer to 10 to the 10th, 10 to the 12th cells. So even if you have a wonderful drug, but 1 in a million cells in the tumor is resistant to that drug on a genetic or epigenetic basis, you lose, and the math doesn't work. So of course the key is to make the math work for you. And so the key is to combine multiple drugs against different targets, where because they're different targets, you hope the toxicities don't overlap in a prohibitive way, and you hope they're not cross-resistant. And so the trick, again, is to try to combine drugs that are not going to be cross-resistant with one another, because then, again, if you had 3 of these drugs, each with a 1 in a million chance of encountering resistance, the chance of any one cell being resistant to all 3 is now 10 to the minus 18th, and now the math works for you. And we know this works because this is what tuberculosis treatment looked like in the United States a century ago before the development of combination chemotherapy. It's why we now control HIV. And I would argue that when we do cure cancers with combination chemotherapy, the same principles apply. In fact, here's a very nice paper by Peter Sorger and his group at Harvard. They used a combination of mathematical modeling and genetic tools to show that curative regimens in lymphoma almost certainly cure because the different drugs in those regimens are truly cross-resistant. So if we're going to get to combination, I think there are a couple of simple things we really need to consider. The first is that I think potency and specificity will really matter as we build these effective combinations. And I like to point out that the best drug for the eventual combination might not be the best drug as monotherapy. When you're using monotherapy, you don't get really penalized enough for off-target effects, and sometimes you actually get rewarded for off-target effects, but that may not be the case when you're trying to build a combination. I think we need to get out of the rotating single-agent mindset, and I think we need to be aware of using all drugs at their single-agent MTD if we're going to build these combinations. And I think we need to perhaps think more creatively about clinical trial design. So for example, I think we see this paradigm all the time, right? So a patient starts drug A, they progress, we stop drug A, we go to drug B, we get a little mileage, we stop drug B, and switch to drug C, et cetera, et cetera. But if we're really trying to get to effective combinations, maybe we should do more and more trials where when the patient progresses on drug A, we keep them on drug A and we see if we can safely add drug B. So the first question would be, do these two drugs play well together? Can you achieve a biologically effective dose of drug B in someone who's already taking drug A? If you can't, you don't go any further, but if you can ask whether you actually rescue any of these patients, whether some of them actually do now respond once you add drug B. And if they do, then that would provide some rationale for later testing the combination versus the single agent. So in closing, I showed you this a moment ago. These were the phase 2 data for the HIF2 inhibitor in kidney cancer. I'm happy to report the phase 3 trial was positive, and the FDA approved the drug based on these phase 3 data for the treatment of sporadic kidney cancer. But of course, this audience knows well that another truism in medical oncology is that most drugs work better in a frontline setting than they do in later lines of therapy. And here we had an experiment of nature that we could take advantage of because there are about 1 in 35,000 people have a germline mutation in that VHL tumor suppressor gene. And not surprisingly, they're at high risk of a number of cancers, including kidney cancer. And so we were able to convince Peloton and then Merck to treat 61 patients with VHL disease who had measurable kidney tumors that had never been treated before. These were patients in surveillance programs because they developed so many tumors over time. They frequently undergo MRI, say every 3 to 4 months, and only if a tumor progresses or changes in some alarming way will they go back to surgery. So here are the swimmer's plots for the VHL patient population. Once again, this is 1 year on therapy. You can see most of the patients were doing well out to 3 years. And if you can read these various diamonds and circles and squares, many of the patients had a response. If you prefer waterfall plots, here's the waterfall plot for the indicator kidney tumors for the patients with VHL disease treated in a sort of pseudo upfront setting with a HIF2 inhibitor. Now, I'm a lumper rather than a splitter, so I would say all of the patients responded somewhat, but if you're a RECIST person, I think they were up to a RECIST response rate of about 60%. Now, to be on the trial, you had to have a kidney tumor, but having VHL disease, these patients often had tumors in other organs, such as hemangioblastomas of the central nervous system and neurocrest tumors of the pancreas called PNETs. So here are the responses of the CNS hemangioblastomas to single-agent HIF2 blockade, and here are the responses to these pancreatic PNETs. Now, I mentioned these patients had been on surveillance programs. So here in gray are the 4 years the patients were on the surveillance prior to going on the HIF2 inhibitor in green. And everywhere you see one of these colored circles, squares, or diamonds, the patient's going back yet again to the operating room to have another tumor removed from their kidney, their brain, their eye, their spinal cord, their pancreas, et cetera. And I think you can see that after they went on the HIF2 inhibitor, the surgeries were greatly decreased. Now, I think all of us, and this is certainly true for me when I was a clinician, we get so used to looking at clinical data, I think it's easy to forget that there are actual human beings linked to each of these bars and triangles and squares. And so I thought to give this a human face, I would share with you the fact that the VHL patients are very well organized and they communicate with one another on social media. So even before the data were publicized, patients on the trial were sharing on their social media sites that they were responding. And imagine you have VHL disease, so you've had this sort of Damocles over your neck, and you've seen this disease ravage your family generation after generation, and you've assumed maybe you're going to die in midlife. And so here's a patient saying, I never thought I'd see this day, and they're describing their tumors getting smaller, being stable, or in some cases disappearing entirely. And because everyone likes a movie, here's a vlog that was sent to me by one of the patients, and I do have permission to show their face. So let's see.
Hey everybody, it's Justin. I just wanted to give you a quick update. I am in a gondola right now in Taiwan. Over there is Taipei 101. The gondola is actually right by the Taipei Zoo. But I just wanted to give you a quick update and say I'm doing well. I'm enjoying my trip. If it wasn't for the PT2977 drug trial, I would have never been able to come out here and do what I'm doing right now. So I just want to thank Peloton, and I hope Merck will fast track this drug for a VHL treatment. So if you guys are listening, hopefully you guys will put it on the market to help VHL. But yeah, keep watching these videos. I'll be making more, and I'll get better at it, and I have to get the angles right because I kind of look fat, you know? Anyways.
So I love that, because at that age, your biggest concern should be whether you look fat on your vlog and not what your next MRI is going to look like. I'm happy to tell you he got his wish. Actually, just based on the phase 2 data, the FDA did approve this drug for the treatment of von Hippel-Lindau disease and its associated neoplasms. That's the good news. This audience might, however, want to know that the trial was so positive so rapidly, because it was the right experiment to do. Let's start in the VHL population, that the approval for VHL disease actually occurred 2 years before the approval for sporadic kidney cancer. The reason I'm telling you that is I've been told by multiple pharmaceutical companies around the world that because of the Inflation Reduction Act, this will probably not happen again. Because you might know that the Inflation Reduction Act clock starts ticking with your first approval. So many companies are rethinking whether they want to go to do proof of concept in a small population before going to the perhaps commercially more attractive population. So this is one of the many things we probably have to try to tweak a little bit in the IRA, because this will stifle the ability to do these types of studies moving forward. The last thing I'm going to say is, I mentioned this was my first time to this wonderful historical meeting, but it's not the first time my late wife came here. So I think, Carlos, one of the reasons you were kind enough to invite me was my late wife was Dr. Kaelin, who was a breast cancer surgeon for many years at the Brigham and Women's Hospital. She actually also became a breast cancer survivor, but then some number of years later developed an unrelated glioblastoma, which took her life in 2015. So I'm very passionate about what all of us are trying to do to help patients. And frankly, there's so much bad news in the world. I'm going to invite you, or maybe implore you or beg you, to see if you wouldn't join me to try to do something which is inherently good today, which is Carlos and I have had the pleasure of working with the great David Livingston. David was probably known to many of you. He was my mentor. He's the reason I became a scientist. And David, as a member of this community, I think developed some of the first high specificity BRCA1 antibodies, and I think was the first to show that BRCA1 was involved in DNA repair. But suffice it to say, David trained many successful physician scientists, and I certainly benefited from his training. And so we're trying to develop an endowed fellowship in David's honor at the Damon Runyon Cancer Research Foundation. We're a little bit over halfway there, but if any of you would be kind enough to scan the QR code and would consider supporting this initiative, I would be deeply appreciative. And other than that, thank you very much for the invitation to speak with you today, and happy holidays and safe travels.
Thank you, Bill, for those lessons, and for that remind us of the rigor we should observe and continue to observe as we develop drugs in breast cancer. Now, I would like to invite Dr. Alexandra Thomas and Dr. Reshma Mahtani to the podium so they can start General Session 1.
Hello? Hello, good morning. It's my pleasure to welcome you all to General Session 1 of the 2024 San Antonio Breast Cancer Symposium. Just as you would expect, we have an exciting and packed agenda. I'm Dr. Alexandra Thomas of the Duke Cancer Institute, and we look forward to moving you through this session this morning.
Good morning. I'm Dr. Reshma Mahtani from Miami Cancer Institute.
Great. With that, we're excited to introduce our first speaker, Dr. Komal Jhaveri, who will present Imlunestrant, an oral SERD as monotherapy and in combination with Abemaciclib for patients with ER-positive, HER2-negative advanced breast cancer, results of the phase 3 EMBER-3 trial.
Thank you so much. On behalf of my investigators and the entire study team, I'd like to thank the organizing committee and the session chairs for this opportunity to present the results of the phase 3 EMBER-3 trial. These are my disclosures. As way of background, we know that ER and CDK4/6 are critical oncogenic pathways and essential therapeutic targets. And even beyond progression, they remain important therapeutic strategies. Indeed, Abemaciclib has shown benefit not only in CDK4/6 naive, but also in CDK4/6 inhibitor pretreated patients. Fulvestrant is the only SERD that is broadly approved as monotherapy and in combination, but the efficacy is limited in patients with ESR1 mutations, and because of the requirement of intramuscular administration, it can be often painful and burdensome to our patients. Elacestrant is an oral SERD with dose-dependent mixed AR agonistic and antagonistic activity approved as monotherapy for patients with ESR1 mutations. Imlunestrant is the next-generation brain-penetrant oral SERD and a pure ER antagonist that delivers continuous ER inhibition. As shown on your right, preclinically and clinically, we've seen activity for Imlunestrant both as monotherapy and in combination with Abemaciclib. And in fact, the combination had a safe tolerability profile. EMBER-3 is a phase 3 global open-label trial enrolling men and women regardless of menopausal status with ER-positive, HER2-negative advanced breast cancer who have had recurrence on or within 12 months of completion of their adjuvant therapy with an aromatase inhibitor with or without a CDK4/6 inhibitor, or progression on first-line therapy in the metastatic setting, again with an AI with or without a CDK4/6 inhibitor, and no prior therapy for advanced breast cancer. A total of 874 patients were randomized using 3 stratification factors of prior CDK4/6 inhibitor therapy, visceral metastases, and region to one of the 3 study arms. Arm A was Imlunestrant alone, administered at 400 milligrams orally daily. Arm B is standard of care endocrine therapy, and Arm C was looking at Imlunestrant plus Abemaciclib. Of note, this third arm was added as a study amendment early in accrual. The trial has 3 primary endpoints. That includes investigator-assessed PFS for Imlunestrant versus standard endocrine therapy in patients with ESR1 mutations and all patients, and Imlunestrant plus Abemaciclib versus Imlunestrant alone in concurrently randomized patients. Other key secondary endpoints and exploratory endpoints are as listed on this slide. The trial utilized a graphical approach wherein alpha was initially assigned to the first PFS analysis of Imlunestrant versus standard endocrine therapy, with majority of the alpha assigned to patients with ESR1 mutations and the remainder of the alpha assigned to all patients. Analysis of Imlunestrant plus Abemaciclib versus Imlunestrant alone was tested in concurrently randomized patients and only tested if one of the monotherapy endpoints was significant. Overall survival was only tested if the corresponding PFS endpoint was significant. 874 patients were randomized, of which 331 were randomized to Imlunestrant alone, 330 to standard endocrine therapy, with majority receiving fulvestrant, approximately 90%, and 213 to Imlunestrant plus Abemaciclib. Again, this third arm was added as a study amendment early in accrual. Baseline characteristics were generally well balanced, including in patients with ESR1 mutations. Overall, approximately 37% had an ESR1 mutation. Approximately 40% had a PI3K pathway mutation, which includes a mutation in PI3K, AKT, or PTEN. And these mutations were detected after randomization prior to study treatment start using a centralized ctDNA assay. Approximately 30% had recurrence on or within 12 months of their adjuvant endocrine therapy, and 60% had progression on their first-line metastatic therapy. Overall, 60% had received a prior CDK4/6 inhibitor, majority being palbociclib or ribociclib. Now moving on to results for the first primary endpoint in patients with ESR1 mutations. Imlunestrant alone significantly improved investigator-assessed PFS compared to standard endocrine therapy in patients with ESR1 mutations. Median PFS was 5.5 versus 3.8 with a hazard ratio of 0.62, representing a 38% reduction in the risk of progression or death. Consistent Imlunestrant benefit was seen across subgroups in patients with ESR1 mutations, regardless of presence or absence of visceral metastases, regardless of prior CDK4/6 inhibitor therapy, or PI3K pathway mutation status. Now for the second primary endpoint, looking at investigator-assessed PFS in all patients, PFS difference of Imlunestrant versus standard endocrine therapy in all patients did not reach significance. The hazard ratio was 0.87. Notably, the majority subgroup of patients without ESR1 mutations showed no difference in PFS with a hazard ratio of 1. Now for the third primary endpoint for investigator-assessed PFS in all patients, Imlunestrant plus Abemaciclib significantly improved PFS compared to Imlunestrant alone in all patients, with median PFS of 9.4 versus 5.5 and a hazard ratio of 0.57, representing a 43% reduction in the risk of progression or death. Again, consistent benefit was seen with Imlunestrant plus Abemaciclib across all subgroups, regardless of presence or absence of visceral metastases, prior CDK4/6 inhibitor therapy, or ESR1 mutation and PIK3CA pathway mutation status. Shown here are the Kaplan-Meier curves for investigator-assessed PFS by ESR1 mutation status. And as you can see, a consistent benefit was seen with Imlunestrant plus Abemaciclib regardless of ESR1 mutation status. Median PFS was 11.1 versus 5.5 in patients with ESR1 mutations as shown on your left, and was 9.1 versus 5.5 in patients without ESR1 mutations as shown on your right. Now in clinic, in the second-line metastatic setting, majority of our patients would have had received a CDK4/6 inhibitor therapy, and treatment selection is predominantly based on a biomarker status. So it was important to evaluate the activity of Imlunestrant plus Abemaciclib in these key clinical subgroups. And as shown here, a consistent benefit of Imlunestrant plus Abemaciclib was seen across these key clinical subgroups. Particularly, 65% of the patients were pre-treated with a CDK4/6 inhibitor prior to being treated on EMBER-3 with Imlunestrant plus Abemaciclib. And here the median PFS is 9.1 versus 3.7 with a hazard ratio of 0.51. Similarly, a consistent benefit was seen in patients with PI3K pathway mutations with median PFS of 7.6 versus 3.8. Shown here are the overall response rates in patients with measurable disease, including in patients with and without ESR1 mutations. On your top row are the overall response rates for Imlunestrant versus standard endocrine therapy, where you can see that the numbers are relatively similar, albeit numerically higher with Imlunestrant, regardless of presence or absence of ESR1 mutations. On the bottom row are overall response rates for the combination versus the monotherapy arms, and here you can see that there is a higher overall response rate with the addition of Abemaciclib, again in all patients, regardless of ESR1 mutation status. Preclinically, Imlunestrant has demonstrated CNS penetrance and activity. So we performed a post-hoc exploratory analysis looking at cumulative incidence rates of CNS progression. And a trend towards lower rate of CNS progression was seen with Imlunestrant. However, the hazard ratio estimate should be interpreted with caution given the low event rate. At this time of interim overall survival analyses with 31% maturity in patients with ESR1 mutations and 23% maturity in all patients, a favorable overall survival trend was seen with Imlunestrant. This maturity was lower in patients without ESR1 mutations at 18%, and the lowest in all patients within the combination therapy comparison at 15%. Now moving on to safety. Overall, Imlunestrant monotherapy demonstrated a generally favorable safety profile. The most common treatment emergent adverse events were fatigue, diarrhea, and nausea, which were no more than 10% increase compared to standard endocrine therapy, and importantly, were majority grade 1 and mainly single episodes. Grade 3 or higher adverse events were reported in 17% in the Imlunestrant arm versus 21% in the standard endocrine therapy arm. Dose reductions and dose discontinuation rates were low at 2% and 4% respectively, and there were no oral SERT-specific safety signals of cardiac or ocular toxicity. While injection site reactions were captured as an adverse event in 9% of the patients receiving fulvestrant, patient-reported injection site pain, swelling, or redness was 72% based on a PRO-CTCAE survey. For the combination, as expected, there was a higher incidence of treatment-emergent adverse events with the most common adverse event of diarrhea. However, again here, the diarrhea was predominantly grade 1, and the safety profile was what we know about Abemaciclib profile and compared favorably to prior reports of fulvestrant plus Abemaciclib with no new additive safety signal for Imlunestrant plus Abemaciclib. In fact, the discontinuation rates for Imlunestrant plus Abemaciclib was low at 6%. So in conclusion, Imlunestrant monotherapy significantly improved PFS compared to standard endocrine therapy in patients with ESR1 mutations, but did not reach statistical significance in the overall population. A consistent benefit was seen across key subgroups, and the overall survival analyses were immature and ongoing. Imlunestrant demonstrated a favorable safety profile with no oral SERT-specific safety signals of cardiac or ocular toxicity. The combination of Imlunestrant plus Abemaciclib significantly improved PFS compared to Imlunestrant alone in all patients, regardless of ESR1 mutation status, achieving a 9.4-month PFS with consistent benefit across key subgroups. The combination had a predictable safety profile, which was comparable to prior studies of fulvestrant plus abemaciclib, with a low discontinuation rate of 6% relative to available combination regimens. And as such, imlunestrant as monotherapy or combined with abemaciclib provides an all-oral targeted therapy option after progression on endocrine therapy for patients with ER-positive, HER2-negative advanced breast cancer. I'm delighted to share that these results are published today in the New England Journal of Medicine and available for your reference. I'd like to thank all the patients and their families and the entire study team who helped facilitate the proper conduct of this trial. And all relevant materials, including supplementary slides, are available behind this QR code. Thank you for your attention.
Thank you so much. Hello? Thank you so much, Dr. Jhaveri. Out of respect to the remainder of our packed agenda, we are going to transition right to our discussant, who will be Dr. Hal Burstein, who will put this abstract in context. Dr. Burstein is representing the Dana-Farber Cancer Institute.
Good morning. I'm delighted to have the opportunity to speak about emerging treatment options for advanced hormone receptor-positive breast cancer. One of the most common mechanisms for resistance to endocrine therapy is the acquisition of ESR1 mutations. These are rarely detected at baseline in primary tumors, but with exposure to endocrine therapy, particularly aromatase inhibitors, we see a higher rate of ESR1 mutation at recurrence or after subsequent lines of therapy. These mutations cluster in the ligand binding domain of the estrogen receptor and yield conformational changes with two clinical consequences. The first is constitutive activity of the estrogen receptor in the absence of estrogen, such that aromatase inhibitors are no longer effective. And the second is diminished binding affinity for SERDs like fulvestrant, such that higher doses of drug, almost twice as high, would be needed to antagonize or degrade the estrogen receptor. And when these mutations were first characterized over a decade ago, it was pointed out right then that the doses at which potent ER inhibition is achieved in the mutant-expressing models might exceed the steady-state intratumoral levels achieved in patients. Because of the importance of targeting estrogen receptor in ER-dependent hormone receptor-positive breast cancers, a number of different approaches are being explored, including novel oral agents that are SERMs, selective estrogen receptor modulators, SERDs, selective estrogen receptor degraders, including elacestrant, which is FDA approved for this indication, Imlunestrant, which we've just heard about, and a variety of other agents, and other drugs that either antagonize or degrade the estrogen receptor, including Protacs, Circas, and Serans. We've just seen the randomized phase 3 EMBER trial, which consists of 3 arms, a standard of care, 90% of which was fulvestrant, compared against the oral SERD imlunestrant or the combination of imlunestrant plus abemaciclib. So who were the patients who entered EMBER-3? These women had an age of 62 on average. 1/3 had progressed after prior adjuvant therapy only. 2/3 had progressed after 1 prior line of treatment for metastatic breast cancer. Roughly 60% had prior CDK4/6 exposure, nearly all of which was either palbociclib or ribociclib, and none of the patients had previously received a PI3 kinase or AKT targeted treatment. Roughly 30 to 40% of the patients had an ESR1 mutation in their tumors. Roughly 40% had a PIK3CA mutation, and by the power of the Venn diagram, roughly 15 to 20% would have had each of those two double hit mutations. You've just seen the primary results for the first half of the analysis. In women whose tumors harbor an ESR1 mutation, there was an improvement in progression-free survival from around 4 months to 5.5 months. And by contrast, if the tumor was wild type for estrogen receptor, the curves were entirely overlapping. Early survival analysis suggests a trend favoring the use of imlunestrant. Now, these data are very concordant with at least 4 other randomized trials, which have compared a standard of care, typically fulvestrant, versus one of the novel oral SERDs or SERMs, elacestrant, camizestrant, giredestrant, or lasofoxifene. And in each of these experiences, we have seen that tumors that harbor an ESR1 mutation have an improvement in progression-free survival, whereas tumors that are ESR1 wild type have no difference with the newer treatment. So why is it that fulvestrant would be less good in mutated tumors but not in wild type tumors? Well, it turns out that in vitro, fulvestrant and imlunestrant have very similar activities, even in ESR1 mutated transfected cell lines. So the IC50 for ER alpha degradation is almost exactly the same in cells that have wild type ER or in cells that have an ESR1 mutation, though you'll notice that the IC50 goes up by about twofold. And if you look at inhibition of cell proliferation or ER degradation in tumors that are ESR1 mutated, you see essentially identical activity in vitro for fulvestrant or for imlunestrant. But as longtime attendees at this meeting know, the dilemma here is fulvestrant dosing. Even with our current high-dose fulvestrant regimen of 500 milligrams given monthly with an extra loading dose in the first month, fulvestrant struggles to achieve a Cmax concentration of greater than around 20 nanograms per mil, and that slides with each month of treatment. By contrast, recent phase 1 data for imlunestrant show that the orally available agent at 400 milligrams rapidly achieves dosing of 80 nanograms per mil on a regular basis, well in excess of the target biologic dose, and well 3 to 4 times higher than what can be achieved with fulvestrant. So the argument here is really that these drugs, these newer SERDs and SERMs, look better largely because of better bioavailability with the oral medication, allowing more effective systemic dosing, and targeting the mutated estrogen receptor gene, which has a higher IC50 threshold than the wild type. Now, also, as you've just heard, these oral SERDs tend to be very well tolerated with few acute side effects, though it is worth pointing out that there are some side effects of these agents. Many of them are associated with GI side effects like nausea, vomiting, constipation, or diarrhea, and several have been associated with bradycardia, photopsia, transaminitis, or hypertriglyceridemia. Aside from the injection itself, which no one would say is fun, fulvestrant is an extraordinarily well-tolerated drug. What about the second half of this comparison, imlunestrant versus imlunestrant plus abemaciclib? As you heard, in the aggregate, this showed an improvement in progression-free survival for the combination of imlunestrant plus abemaciclib versus imlunestrant alone. And that makes this the first instance where we've really begun to see oral SERDs break out from the ESR1 mutation box, if you will, perhaps reflecting the idea that a more active endocrine agent in combination with effective targeting using crosstalk pathways in tumors that are fundamentally ER-dependent can really transform the natural history of the disease in both ESR wild type and ESR mutated patients. Now, a couple comments on the design considerations of this trial. The first is that the imlunestrant plus abemaciclib arm really lacks a standard control, and we don't know how this would have compared to, say, fulvestrant with abema, or fulvestrant with alpelisib, or fulvestrant with capivasertib. Secondly, not all the patients had previously had a CDK4/6 inhibitor, only 60%. And one wonders if the driver for this outcome is largely the fact that they're now getting a CDK4/6 inhibitor for the first time. For a couple of reasons, that probably is not the explanation. The first is that in the forest plot subset analyses they showed, it is ironically the women who had prior CDK4/6 exposure that actually derived the most benefit for the combination arm compared to the imlunestrant alone arm. And paradoxically, after all the data we've seen in recent years, there did not seem to be a significant benefit for actually adding CDK4/6 inhibitor in that group of women here that were CDK4/6 naive, perhaps simply a reflection of small size of the study. The other reason is, as you've heard, that patients with prior CDK4/6 treatment actually did quite well with the combination here. Imlunestrant with a median progression-free survival of around 4 months, out to about 9 months with the combination. Now, on my next slide, I have assembled a list here of the median progression-free survivals in recent randomized trials of patients who had substantial exposure to prior CDK4/6 inhibitor treatment. Before you start angry tweeting me, I want to acknowledge that this is a cross-study comparison. These are unplanned subset analyses. They differ by the extent of prior therapy, variable tumor genomics and biomarker profiles, different standard of care options, sample size, exposures, and investigator versus blinded central review report. So if there are any students or biostatisticians in the audience, please just cover your ears for the next moment or so. But if you look at these trials across a spectrum here that includes standard of care versus an oral SERD or SERM, standard of care with or without the addition of an AKTI, standard of care with or without the addition of a second line of a CDK4/6 inhibitor from the PACE, MAINTAIN, and post-MONARCH trials, and finally, on the far right, the EMBER-3 result in patients with prior CDK4/6. The blue lines here represent the standard of care. And what you can see is that variably we see modest improvements in progression-free survival with the newer approaches, but qualitatively and quantitatively, it is impressive that the Imlunestrant plus Abemaciclib combination seems to tower over the rest with nearly twice the improvement in progression-free survival out to around 9 months. Well, is there other evidence that using an oral SERD or SERM in combination with Abemaciclib in patients with prior CDK4/6 inhibitor treatment might uniquely benefit from this combination? And there are a couple of clues. We've seen the data just now from EMBER-3. At this meeting, there are data being presented for the combination of elacestrant plus Abemaciclib in a small experience, but with a 9-month median progression-free survival. And in a previous publication looking at lasofoxifene plus Abemaciclib, entirely in a cohort of patients with ESR1 mutated tumors, median PFS was over a year. So this is very intriguing to me that a combination of a non-cross-resistant CDK4/6 inhibitor combined with a more potent endocrine therapy might truly lead us to a better long-term outcome. One more note before getting to some discussion points. Finally, if you look at survival with Imlunestrant plus or minus Abemaciclib, these data are very immature. Only 15% of the events anticipated for a planned analysis have happened. But at the moment, there are more deaths in the combination arm. And it seems unlikely that you would get regulatory approval until that has followed itself for longer periods of time, and we are assured of the safety of the combination. So a quick summary. Imlunestrant is a well-tolerated oral SERD. As monotherapy, oral SERDs, including Imlunestrant and previously elacestrant, have more activity than fulvestrant in ER-positive advanced breast cancers with ESR1 mutations, likely owing to bioavailability and dosing considerations. Emerging data suggests that combining new oral SERDs, including Imlunestrant, with a second-line CDK4/6 inhibitor such as Abema, can achieve substantial durations of tumor control irrespective of ESR1 or PIK3CA status, and this may well foreshadow a future treatment option. It also underscores the importance of ongoing targeting of ER and crosstalk pathways in tumors that, even though they're resistant to our endocrine treatments, remain fundamentally dependent on ER. So what are the next steps? Short-term priorities include longer follow-up for EMBER-3. I'm very interested in tailored approaches based on monitoring for acquisition of ESR1 mutations on liquid biopsy and then switching to an oral SERD. We've seen clues that this can be an effective approach with the PADA-1 trial, which randomized patients to fulvestrant instead of an AI with ongoing CDK4/6 inhibitor. The SERENA-6 trial has a fundamentally similar design looking at camizestrant. SERDs, CDK4/6 inhibitors, and PIK3CA pathway inhibitors are proliferating at a rapid rate. There are almost too many possible combinations or sequences to explore, but they need to be done. Finally, and perhaps most importantly, I'm keen to see whether or not these oral SERDs will improve outcomes in tumors that are endocrine sensitive and not so resistant, or in early stage breast cancer. A variety of adjuvant trials are being mounted globally. Fundamentally, these come in two classes. As initial therapy, standard of care treatment with, say, tamoxifen, ovarian suppression, or an AI is being compared against SERDs in the Cambria-2 trial, in the lidERA trial. And then there's another set of trials which take patients who've been cancer-free for 2 to 5 years and randomize them again to ongoing standard endocrine therapy versus introduction of a SERD, as in the Cambria-1, ELEGANT, and EMBER-4 trials. I would only point out that at present these trials are not designed to capture the potential clinical interactions between SERDs and CDK4/6 inhibitors, and are potentially vulnerable to unknown variations in the frequency and timing of the acquisition of ESR1 mutations, if that's a key subset, or other features of endocrine resistance, which to date have been the context where we have seen SERDs outperform our standard therapies. Finally, I took a stab at trying to figure out where such a combination of an oral SERD plus a CDK6 inhibitor, such as Abemaciclib, might fit if it were to be approved and available in a larger context of treating advanced breast cancer. I apologize. I broke this out by the adjuvant therapy patients had received for patients who've had either no adjuvant treatment, tamoxifen, or remote exposure to an AI. Largely, we are using an AI plus a CDK4/6 inhibitor in the first line. For patients who progress on an AI, fulvestrant plus a CDK4/6 inhibitor remains the standard, though there is an interesting option for those with PIK3CA mutations that we heard about at this meeting last year of including a combination of a CDK4/6 inhibitor with a PI3 kinase inhibitor. It's really in second line that you might see a lot of interest in the near term in these combinations, where we stratify patients by genomic signatures for their tumor, and then could frequently find opportunities to use a combination of a SERD and abemaciclib if the data continue to mature and evolve the way they are. With that, it's a pleasure to acknowledge my Dana-Farber colleagues, Renath Jesselson, who will be speaking later today, talking in more detail about SERDs, Erica Mayer, Sarah Tallaney, and Miles Brown for their invaluable discussions, Dr. Jhaveri for a wonderful presentation, and the Eli Lilly team for sharing materials ahead of time, and the San Antonio organizers for the invitation to be a discussant. Thank you very much.
Thank you, Dr. Burstein. I'd like to now call to the stage Dr. Binghe Xu from Cancer Hospital, Chinese Academy of Medical Science, who will be discussing pyrotinib or placebo in combination with trastuzumab and docetaxel for untreated HER2-positive metastatic breast cancer, pre-specified final analysis of progression-free survival of the phase 3 FILA trial.
Thank you, Chairman. Good morning, ladies and gentlemen. It's my great honor to be here to share the results of final analysis of PFS from the FILA trial, the randomized phase 3 study to compare pyrotinib or placebo in combination with trastuzumab and docetaxel for untreated HER2-positive metastatic breast cancer. Here's my disclosure information. Cleopatra study established dual anti-HER2 plus docetaxel as a first-line standard of care for HER2-positive metastatic breast cancer. The median or PFS with trastuzumab, pertuzumab, and docetaxel was 18.7 months, which was longer than 12.4 months with placebo, trastuzumab, and docetaxel. Hazard ratio was 0.69. OS was 56.5 months compared to 40.8 months. Hazard ratio was 0.68. The drug pyrotinib is different from monoclonal antibody pertuzumab. It is a small molecular tyrosine kinase inhibitor that cannot be reversed and targets EGFR, HER2, and HER4. Here, we did the FILA study to compare the pyrotinib with placebo in combination with docetaxel and trastuzumab in untreated HER2-positive metastatic breast cancer. Interim analysis showed the combination of pyrotinib can significantly improve the PFS compared to with placebo combination. However, the OS data was not mature at that time, so here we present the pre-specified final analysis of PFS as well as long-term efficacy and safety outcomes following additional 2 years follow-up. In the study, the patients with histological and confirmed HER2 positive recurrent or metastatic breast cancer that cannot be who have not been treated before. Patients were divided into two groups: one receiving paratinib, the other receiving placebo. The primary endpoint was investigator-assessed PFS. We assume that the median PFS would be 16.5 months in the paratinib combination, 12.5 months in the placebo combination, with a total of sample size 590 patients, including approximately 410 PFS events. At a significant level of 0.025. Final analysis of PFS was supposed to be done 410 PFS events happened. As of April 13, 2024, we recorded 408 PFS events, so the significant threshold was recalculated at one side p-value was 0.0231. A total of 590 patients were enrolled. 497 were assigned to the paratinib group and 293 to the placebo group. The median follow-up duration was 35.7 months in the paratinib group and 34.3 months in the placebo group. As of data cutoff, 91 patients in the study group and 26 patients in the control group were still undergoing treatment. Here's the final analysis of PFS. The median PFS was 22.1 months in the paratinib combination and 10.5 months in the placebo combination. Hazard ratio was 0.44. One-sided p-value was less than 0.0001. 3 years PFS rate was with paratinib combination was 30% higher. The paratinib combination remained substantially consistent in the benefit of PFS across almost all analysis of the subgroup. Among patients who had not received the pre-neoadjuvant and adjuvant trastuzumab, the combination of paratinib reduced the risk of disease progression or death by 75%. Among those who had not received the previously adjuvant and neoadjuvant trastuzumab, the risk was lowered by 54%. For the patients with treatment-free interval between 12 months and less than 24 months, the combination of paratinib reduced the risk of disease progression or death by 79%. For those with treatment-free interval at least 24 months, the risk was lowered by 47 months. So combination of the Pretreated had a better overall survival compared to placebo combination. The median OS was not reached in either group, but we can see the survival outcome, the overall survival curves started to separate as early as 6 months. The improvement in overall survival remained consistent with a 10% increase in survival at 4 years. It was noted that more patients received additional therapies after treatment discontinuation. Although crossover was not allowed in either group, but we can see the half of the patients received the Pretreated containing therapy in the placebo group. Combination of Pretreated also had a good benefit in tumor response. 84.2% of the patients in the study group and 71% of the patients in the control groups had achieved the clinical benefit, objective response. The duration of response was 22.3 and 10.4 months, respectively. The safety profiles in the updated analysis remained consistent with those reported in the previous interim analysis in terms of frequency, severity, and specificity. No new safety issues were found. No treatment-related deaths in Pretreated combination, but one patient died in the placebo combination due to treatment-related adverse events. As we reported previously, the diarrhea's most common adverse events associated with Pretreated. Grade 3 diarrhea was found, reported in 47.8%, mostly during the first course of treatment, around 9 days after starting. The most common grade 3 or worse treatment-related adverse events was decreased neutrophil count and decreased white blood cell count. In conclusion, after an extended follow-up, the updated analysis showed Pretreated combination provides sustained longer PFS compared to placebo combination in the first-line treatment of HER2 positive metastatic breast cancer, which translates into potential longer OS. The safety profile of Pretreated combination remained manageable throughout the extended treatment duration. The updated analysis further confirmed Pretreated plus trastuzumab with docetaxel is a well-established and effective treatment strategy for this group of patients. Finally, I want to give a big thanks to all patients and their families, FINA study team, and the staff of sponsor. I also want to thank San Antonio Breast Cancer Organization for inviting me to present the result of Pretreated study for the third time. Thank you for your attention.
So we do have a couple. We do
Dr.
have a
Hsu,
couple moments.
Dr. Hsu, don't go anywhere. We might have a question or two.
So we do have a couple minutes for questions. If you have a question, please go to the mic and state your name and affiliation. While we're waiting.
Dr. Hsu, if it's okay, while we're waiting, I'm just going to go ahead and ask a question. Can you tell us more about how long the docetaxel was given? Was it given indefinitely for these patients, or was it stopped at some point? The chemotherapy component of the regimen, was it continued indefinitely, or was it held at any point in this regimen?
Docetaxel?
Yes, sir.
Yeah. I'm not sure the how long the docetaxel, but we are seeing some slides shows this. I think for the docetaxel plus pertuzumab and for trastuzumab and Pretreated, the most common adverse events was diarrhea. Docetaxel also causes the white blood cell count, so patients cannot use the long time. Usually, I think it's about 8 months, like this.
8 months. Okay, thank you. We have a question at microphone 5.
Hi, my name is Hans-Christian Koberg from Germany, and I have a question regarding the comparison to Cleopatra trial, because we have your really good 22 months of PFS for your study group, but you compare that to a standard that has been already been the control group in the Cleopatra trial, and that was comparable, the 10 to the 12% months. But if you think about the almost 19 months in the Cleopatra trial, how do your data compare to those? Do you think that would still be a significant difference, or rather a trend?
That's good questions. Our study shows the longer PFS compared to the control arm, but we control arm use a single antibody, the trastuzumab plus docetaxel. I think it's not a standard of care for in the Western country. But when we started this clinical trial, the trastuzumab, pertuzumab, and docetaxel was not approved in China. I think this regimen was approved in China in December 2019, and our study designed in 2018. First, the patients enrolled in June 2019. So we choose the docetaxel plus trastuzumab as the control arm. Following our study, we can see the control arm, the PFS is the same as the reported previously for other investigators. So I think this the Pretreated small molecular tyrosine kinase inhibitor, and trastuzumab is the monoclonal antibody. So this drug combined could produce the higher good result, because more patients use the adjuvant or neoadjuvant therapy with the trastuzumab and pertuzumab. If the patients use this agent, we can see the PFS was longer than not use the trastuzumab and pertuzumab.
Dr. Hsu. Thank you.
Thank you.
In the interest of time, we're going to move on. Our next presenter is Dr. Junji Li from Fudan University Shanghai Cancer Center, who will be presenting on HER2-directed antibody-drug conjugate SHRA-1811 in the neoadjuvant treatment of HER2-positive early breast cancer, a prospective randomized open-label phase 2 study.
Okay, thank you. Dear audience, thanks the organizer for the invitation. It's my great honor to have the opportunity to present the phase 2 randomized trial, Fascinate-N, to evaluate HER2-directed ADC, SHRA-1811, in the neoadjuvant treatment of HER2-positive breast cancer. The primary investigator is Dr. Zhiming Shao from Shanghai Cancer Center, Fudan University, and I have nothing to disclosure. So, neoadjuvant treatment is routinely recommended to stage 2 and 3 HER2-positive breast cancer. And now a 4-drug combined regimen, taxane, platinum, trastuzumab, and pertuzumab, is the preferred choice according to NCCN guidelines with PCR rate up to 60%. So, HER2-directed ADC, such as T-DM1, TDXD, has shown remarkable efficacy in the metastatic breast cancer and now being evaluated in neoadjuvant settings. For example, the Christina trial shows T-DM1 plus pertuzumab was inferior to TCB-HP, and now DB11 is ongoing to test TDXD-based neoadjuvant treatment. SHRA-1811 is a third-generation HER2-directed ADC composed of trastuzumab, Clinbo linker, and also top-I isomere-1 inhibitor payload with highly membrane permeability and potent cell-killing effect. The DAR is 6, and in the previous global phase 1 trial, in the dosage of 4.8 and 6.4 milligram per kilogram every 3 weeks, SHRA-1811 is quite efficacy. In heavily treated HER2-positive breast cancer, the overall response rate is 76%. So Fascinate-N is a prospective randomized umbrella trial conducted by Fudan University Shanghai Cancer Center based on precision platform. We use multi-omics characteristics to divide the patients into different subtypes. The luminal type and the triple negative by Fudan classification. The detailed subtype methods can be seen in reference 2 and 3, and the HER2 by hormone receptor status. So patients with different characteristics were randomized to the standard to the study group to receive precision-based treatment, or to the control group to receive standard neoadjuvant treatment. So the detailed definition about the design of the Fascinate-N can be seen in the reference 1. So we have 2 co-primary endpoints. The first is whether the total PCR in the study group is better than that in the control group to definite the necessary and efficacy of the subtyping. And the second is to test each precision-based arm, whether the PCR rate is better than the control group arm through Bayes methods. So each arm was planned to test a minimum of 20 patients and a maximum of 120 patients. And we will evaluate periodically after every 20 patients in each arm got operation. So if the probability of a precision-based arm is higher than that of the control arm, greater than 95%, this arm was thought to be graduated from the trial for efficacy. And if the probability is less than 5%, the arm was dropped for utility. So pathology confirmed HER2-positive breast cancer with stage 2 and stage 3 by hormone receptor status were randomized to receive 24 weeks period of neoadjuvant treatment. In the group A is SHRA-1811 monotherapy, 4.8 milligram per kilogram every 3 weeks for 8 cycles, and group B adding piratinib and oral TKI for anti-HER2, just mentioned in the previous presentation, when combined with docetaxel and trastuzumab, it's quite effective in the first-line treatment of HER2-positive breast cancer. And group C, nab-paclitaxel plus carboplatin and trastuzumab and pertuzumab. So about 298 patients were screened and 265 patients were enrolled. Safety profile was accessed to patients receive at least 1 dose of the treatment group, and 6 patients who refused to surgery or refused to discontinue the treatment was considered as non-PCR. As we mentioned before, after every 20 patients in each arm have the operation, we will calculate the PCR rate. So on the basis of the Bayes analysis, This slide shows the first 60 patients in each arm got operations, and the result indicates the result of occurrence between the treatment arm. So the enrollment was closed, and finally 265 patients was enrolled. So here shows the basic characteristics. About 55% were hormone receptor negative. And we try to enroll patients with a higher tumor burden because for those with low and medium tumor burden, HER2-positive breast cancer, we believe de-escalating neoadjuvant strategy is sure to be explored. So about over 90% were node positive and 70% were stage 3. Although with the heavy tumor burden, the result was quite promising. The PCR rate is 64%, and in hormone receptor negative patients is 75%, and in triple positive patients it's about 50%. No statistical difference among each study group. And here shows the best percentage changes from the baseline tumor diameters was recorded by breast MRI after every 2 cycles. So the blue line shows the patients got finally clinical complete response, and the yellow lines is clinical partial response. The tumor shrink rate is almost the same among the 3 groups, about a 55% decrease after cycle 2 and a 75% decrease after cycle 4. So the forest plots further indicated the similar efficacy among each group, both in the pre-specified and the post-hoc subgroup. Interesting data is if the patient is primarily with stage 2 disease, SHRA1811 monotherapy can achieve a PCR rate over 89%. So 24 patients out of 27 patients got PCR. And in patients with primary stage 3 disease, when adding beratinib, the PCR rate is up to 65%, which is interesting and need to be further investigated. The side effects, when combined with the PCBHP, SHRA1811 monotherapy has a numerically lower rate of dose reduction and a lower rate of drug discontinuation. Lower rate about the anemia, diarrhea, alopecia, and neuropathy. Only 1 patient in patients with the SHRA1811 recorded grade 2 ILD. And when combined with beratinib, higher rate about grade 3 and above side effects, especially for the diarrhea and mucositis oral. So this is the first study to report a 3rd generation HER2-direct ADC in the neoadjuvant treatment of HER2-positive breast cancer. And we believe SHRA1811 is quite efficacy and well tolerated. So let me explain the clinical value of the current study. So the standard 4-drug combined regimen is quite efficacy with the PCR rate up to 64%. It is quite challenging to identify a better regimen which can improve the PCR rate, both statistically and clinically. We can calculate the sample size we need to launch a phase 3 trial. So if we believe now we are in the era of ADC with comparable efficacy, SHRA1811 might serve as a backbone, and then we can test the era of ADC plus. Although in the current study, when combined with beratinib, we cannot improve the PCR rate in the whole population and with higher side effects. But in the future trial, we can test to combine with pertuzumab, to combine with immunotherapy, or even combine with endocrine therapy in triple-positive breast cancer. So according to my opinion, maybe 1 can substitute for 4 and then add more. So many thanks to the patients and their families, and also the investigators and the researchers in the neoadjuvant study group. And also a huge amount of work has been done by our pathologists. I really want to thank my colleagues from breast surgery department because we do over 10,000 cases, breast cancer cases every year, really facilitate and really accelerate the enroll period in around 1 year. And the last slide is a picture of all my colleagues in breast surgery department. In the middle is Dr. Zhiming Shao, our director, and he will present a primary result of a phase 3 trial in the neoadjuvant treatment of triple-negative breast cancer the day after tomorrow in Journal Section 3. So that's all for today. Thank you.
Thank you. Thank you for catching us up on time here. If there are questions, please go to the microphones. I think Is there a question at 6? No.
Great, great. Well, thank you so much, Dr. Lee. Wonderful presentation. We do have a question from online. In the case of a PCR following neoadjuvant therapy, what kind of adjuvant therapy was given to these patients?
So in the study group, if the patient got PCR, we will continue trastuzumab and pertuzumab for the total 1 year. And if the patient is not PCR, we will suggest PCBHP 4 or 6 cycles, depends on the tumor resistant burden. Yeah.
Great, thank you.
I think we're going to move on. Thank you so much. Now, to put these abstracts into context, it's my pleasure to invite Dr. Aleix Prat from the Clinic Barcelona Comprehensive Cancer Center. Dr. Prat.
Good morning. Thank you, Dr. Thomas, Dr. Mahtani. Also want to thank the scientific committee for inviting me to discuss these two very interesting oral presentations. And in the next 15 minutes, I will try to be on time. The title of my talk is the one you can see here, Dual HER2 Blockade, Anti-HER2 ADC, or both, Lessons Learned from Clinical Trials. Before I begin, I do want to disclose that I will briefly discuss a particular finding from the HER2-DX assay in one particular slide, and this is an assay that I have co-developed with Reveal Genomics. So today we've learned about pirotinib. It's not a new drug, but probably for most of the audience, this is a drug that is not widely used and is not even available. Just as a brief reminder, pirotinib is an irreversible inhibitor, TKI, against HER1, HER2, and HER4. And from a chemical formula perspective and mode of action and also toxicity profile, it looks very similar as neratinib, a drug that probably you are more aware of. Pirotinib has been already approved in China based on the results of this phase 3 clinical trial, the PHOEBE study, 267 patients with metastatic HER2-positive disease that had previously received anti-HER2-based therapy. These patients were randomized to capecitabine pirotinib or capecitabine lapatinib. The results were published in Lancet Oncology a few years ago, showing an improvement in progression-free survival, you can see here, from 6.8 months to 12.5 months. I would like to also highlight that despite the efficacy, toxicity is an issue. Regarding grade 3 or more diarrhea, this happened in this trial in 31% of the cases versus 8% in lapatinib. Today we've learned the results, the updated results of the FILA phase 3 clinical trial in a first-line setting. Just a brief reminder of the design. We're talking about 590 patients that participated. These were patients treatment naive for metastatic HER2-positive disease. They had at least one measurable lesion and ECOG 0 or 1. These patients were randomized to trastuzumab docetaxel without pertuzumab, so this is not the standard of care for most of us, versus docetaxel, trastuzumab, and pirotinib with a dose of 400 milligrams a day. The primary endpoint was progression-free survival. As has been shown previously, the results show that the primary endpoint was met. Regarding median PFS with pirotinib, it was 22.5 months versus 10.5 months with a hazard ratio of 0.44. But again, one issue of this drug is toxicity in the terms especially of diarrhea. Grade 3 or 4 diarrhea happens in almost 50% of the patients compared to 4.4% in the control arm. Regarding overall survival, there was a clear hint that this drug improves overall survival, and this is interesting because 52% of the patients did not receive any more anti-HER2-based therapy after pirotinib, and 76% did not receive therapy after HT arm. So I think what this tells us is that the first-line therapy for metastatic HER2-positive disease is critical for improving overall survival. You might be asking, and I think somebody from the audience asked this question, how does these results compare to THP? So this is a table that compares the clinical pathological characteristics, some of them together with activity, overall response, and median PFS, with single blockade or dual HER2 blockade in the FILA study, in the Cleopatra trial, and also in the Peru study. What you can see in general is that there are no major differences regarding hormone receptor positivity, HER2 3+, visceral disease, no previous systemic therapy, or even prior trastuzumab. Regarding overall response and median PFS with a single taxane and trastuzumab, also quite similar, overall response around 70% and median PFS of 10 to 12 months. In the context of single taxane and dual HER2 blockade, also results very similar, overall response around 80% and median PFS that goes between 19 to 22 months. So overall, very comparable with the two regimens. Again, I would like to highlight the grade 3 or more diarrhea, almost 50% in FILA versus 8% in Cleopatra. So this is a major difference. I think this particular context of first-line metastatic disease also poses the question of if we can identify patients that are going to be long-term responders, meaning they're going to be on therapy, especially maintenance with HP for many years, as we see every day in the clinic. Of course, there's much work being done and much work to be done. I just want to highlight one finding from the HER2-DX RBB2 score that was presented this morning by Javier Cortés from the Cleopatra tumor samples, 214 tumor samples from the THP arm, showing that despite all these tumors being HER2 positive, the levels of RBB2 are important for progression-free survival and overall survival independently of all the known clinical pathological variables, including IHC, HER2 2+ versus 3+. And I would like to highlight the overall survival results where RBB2 high tumors achieve a median overall survival of 73 months versus 40.3 months in RBB2 low, which is a difference of more than 30 months between the two groups. Of course, this is not the only variable that has been associated with long-term responders. Sandra Swain and colleagues reported a few years ago in this trial that other variables such as non-measurable disease, non-visceral, progesterone receptor positive, HER2 3+, and PIK3CA wild type are associated with long-term responders, meaning be on therapy for more than 35 months. So I do think that in the future, combinations of one or several of these variables will allow us to better identify those patients that we can be more reassured to start with THP. This is important because new studies are coming that could be practice-changing in the future. One of them is the Destiny Breast 09 study. Here we're talking about 1,134 patients in first-line setting being randomized 1:1 to TDX placebo, TDX pertuzumab, or here the THP control arm. So we are awaiting these results. At the same time, this trial poses an interesting question that will be asked, that is, what is the role of dual HER2 blockade in the context of a potent anti-HER2 ADC such as trastuzumab and deruxtecan? Other studies are also ongoing. One of them is the HER2 CLIMB-05. This is a study in both hormone receptor positive and hormone receptor negative. Patients have to receive 4 to 8 cycles of induction with THP, and if their disease is unstable disease or response, they are randomized to maintenance with HP versus HP with tucatinib. We have other ongoing studies in a more selected group of patients. The concept is similar, first 4 to 8 cycles of THP induction, and then depending on the characteristics, if the tumor is hormone receptor positive, the PATINA and the HEREDA trial randomize patients to either HP palbociclib or HP giredestrant, whereas INAVO 122 focuses on those patients with PIK3CA mutations and randomizes patients to HP inavolisib. All of them, the control arm is HP. Tomorrow, we heard today that we're going to see the results, the primary results of the PATINA trial, so please stay tuned on that. So the take-home messages of this first part, focusing on first-line metastatic HER2-positive disease, is that, in my opinion, dual HER2 blockade with a single taxane remains the first-line standard of care, that pirotinib is oral but more toxic, especially diarrhea is an issue, compared to trastuzumab, pertuzumab, although we don't have direct comparisons available today. That optimizing first-line therapy seems to be crucial to improve overall survival in these patients. That enhancing outcomes in this particular context of first-line HER2-positive disease might be challenging, given the high standard already set. But many pivotal trials, as you can see, are ongoing, and we await results. Again, let's stay focused for tomorrow's presentation on the PATINA trial. And also, I do think that biomarkers, here a few of them, may guide treatment in this context, balancing toxicity, efficacy, cost, and patient preferences. Following, another aspect I think to try to answer is, again, the question that I posed before: what is the value of adding a second anti-HER2 agent when combined with an HER2 ADC? We don't have much data, but we do have some data, mostly focused on TDM1. In studies that have randomized TDM1 with another anti-HER2 agent. We have the HER2 CLIMB-02 study with TDM1 plus minus tucatinib. That is positive. There was a benefit of adding tucatinib, although I'm not putting this in green color. It's in yellow because the absolute benefit of adding tucatinib on top of TDM1 was modest. And we have the Marianne study looking at TDM1 plus minus pertuzumab that did not show an effect of pertuzumab in combination with TDM1. The other question that needs answers is what is the activity of HER2 ADCs beyond TDM1, especially these potent anti-HER2 ADCs in early stage HER2-positive breast cancer. So here is where the second presentation comes in, the FASCINATE-N HER2-positive study. This drug called trastuzumab deruxtecan is a HER2 topo-1 ADC with a DAR 6. This is a study that, although recruited stage 2 disease, mostly these patients had stage 3, 70% had stage 3, 90% had no positive disease, and 55% were hormone receptor negative. Patients were randomized to monotherapy, to the ADC. The combination of the ADC with pirotinib, but here with a lower dose, instead of 400 milligrams, 200 milligrams a day, and the control arm with paclitaxel, carboplatin, trastuzumab, pertuzumab. 6 months for the 3 arms and then surgery. In terms of toxicity, we saw the comparison. Basically, the single-arm ADC is still toxic. Grade 3 and 4 proportions are even slightly higher than multi-agent chemo and HP, although there's a bit lower discontinuation. The toxicity profile of the ADC monotherapy compared to the multi-agent chemo HP is slightly different as well. The ADC induces more nausea and vomiting and oral mucositis and grade 3 neutropenia, whereas the multi-agent chemo induces more alopecia and more peripheral neuropathy. What is also clear in this trial is that the combination of the ADC with pirotinib is very toxic. Grade 3 and 4 rates were very high, 72%, and 30% had to discontinue. So definitely this is a very toxic combination. In terms of activity, looking at PCR rates, as was seen, there are no major differences. The estimates look comparable across the 3. So clearly, adding a second anti-HER2 agent to a potent ADC does not seem to increase PCR rates. And this is interesting, and I want to stop just for a minute to review what are the main biological drivers in HER2-positive disease that explain achievement of PCR in the context of chemotherapy and dual HER2 blockade. This is a review that we wrote quite recently together with our colleagues at Dana-Farber, led by Dr. Ada Wachs. Basically, there are 4 main biological drivers of PCR. One of them is proliferation. The other one is more expression of HER2. The other one is less expression of the ER signaling. And the other one is more immune infiltration, B cells and T cells. Basically, what we've seen now across many studies is that when the 4 are met, and this happens in around 1/3 of patients with HER2-positive disease, we identify a group of patients with very high chemosensitivity of their tumors and very high sensitivity to dual HER2 blockade. So the 2 variables go together, and it's going to be very difficult to dissect one versus another one. And this brings me on a potential hypothesis of why doesn't dual HER2 blockade boost PCR rates compared to just a single potent ADC. In this particular context of a potent HER2 ADC, the chemotherapy component might be more important for explaining the PCR and less so the anti-HER2 component, whereas in a context of more standard chemo, just as THP or taxane carbo HP, the anti-HER2 component adds more than the chemotherapy component. So the hypothesis here is that potent ADCs delivered chemo may overshadow dual HER2 blockade effects. Of course, this is a hypothesis. More studies are needed to conclude if this is true. And we have trials in this particular context that may answer these questions. One of them that we are awaiting results is the Destiny Breast 11 study. It's a neoadjuvant study in patients with node-positive disease, large tumors, or inflammatory breast cancer. These patients have been randomized to trastuzumab deruxtecan for 8 cycles, TDX 4 cycles followed by THP 4 cycles, or the control arm, AC times 4 versus THP times 4. So again, we will see the results of this study. There's another strategy in this context with ADCs in HER2-positive disease, which is to focus on patients with residual disease, so to focus in the adjuvant setting. There are 3 pivotal trials ongoing in this context, both in ER-positive and ER-negative, the DESTINY-Breast05, the COMPASS HER2 residual disease, and Estefania, the control arm being TDM1 for 14 cycles, DESTINY-05 looking at TDX for 14 cycles, COMPASS residual disease looking at the combination of TDM1 tucatinib, and Estefania looking at the combination of TDM1 atezolizumab. At the same time, the field is moving to try to decrease the amount of chemotherapy that these patients did receive in the context of dual HER2 blockade. One of these efforts is the COMPASS HER2 PCR trial, which is ongoing, has already recruited more than 2,100 patients, so we await the first results next year. Stage 2 up to 3A, ER-positive and ER-negative. All these patients receive 3 months of a single taxane, trastuzumab, pertuzumab, and if they achieve a PCR, no more chemo is administered in the adjuvant setting, and HP is continued to complete 1 year. This is a trial led by Kaklamani, and the PI is Nadine Tong. At the same time, the field is trying to see if patients could be treated without any chemotherapy, just dual HER2 blockade. The FERGAIN study was one. Now we have the FERGAIN 2 ongoing, almost 400 patients, stage 1, stage 2, tumors up to 3 centimeters, node negative, ER-positive and ER-negative. These patients receive 6 months of HP without chemo, and if they achieve a PCR, no more chemo is administered in the adjuvant setting, and patients continue with HP. This trial is led by Metzir, and the PI is Dr. Antonio Llombard. So the take-home messages to finish in this context of early-stage HER2-positive disease is that this ADC shows, as monotherapy, high activity in early-stage HER2-positive breast cancer, that the combination of this ADC with pirotinib shows toxicity, very important toxicity, without added efficacy, questioning if chemotherapy is dominating the dual HER2 blockade effects, that the role of HER2 ADC monotherapy in early-stage HER2-positive disease is challenging, especially as the upfront treatment option. So we need more results. Of course, we are awaiting the result from DESTINY-11. The question here is, will TDX prove superior, not only equal, but superior to ACTHP and more tolerable? And finally, I do think that biomarkers are needed today and in the future, and there are many decisions that need to be made with different therapies. We're going to have more therapies in the future, so without those biomarkers, it's going to be difficult to make those decisions. And I just want to finish by acknowledging colleagues, friends that have bring a lot of value when I was preparing this presentation. Thank you very much.
Thank you, Dr. Prat, for that excellent presentation. Our next presenter is Dr. Maria Margarete Karsten from Charité Universitätsmedizin, Berlin. She'll be presenting on PRO-B, a superiority randomized controlled trial evaluating the effects of symptom monitoring in metastatic breast cancers.
Yes, good morning. Thank you for the introduction. I feel very honored to be able to present the results of the PRO-B trial here today. These are my disclosures. Patient-reported outcomes, often abbreviated also as PROs, have been defined by the FDA in 2009 as any report of the status of a patient's health condition that comes directly from the patient without interpretation of a clinician or anyone else. There is increasing evidence in clinical medicine that the use of PROs supports patients through symptom monitoring during their medical treatment, improves adherence to oral cancer therapeutics, reduces unplanned emergency room and hospital admission, and even prolonged survival in 2 monocentric trials for patients with advanced disease, all the while enhancing communication between patients and the care team. Despite this growing evidence, uptake in clinical cancer care for PRO monitoring has not been as fast as one would think. This was the rationale behind designing the PRO-B trial, a multicentric randomized controlled trial, including 52 centers all across Germany, ranging from small community hospitals in rural areas to large cancer centers in metropolitan areas. Patients who were treated in a participating center for metastatic breast cancer with a life expectancy of more than 3 months, under active treatment and able to read and comprehend German, as well as having access to a mobile device were eligible to be registered in the ProB trial. They were then randomized according to the following strata: localization of their metastasis, histological subtype of the tumor, and type of study center. Patients in the intervention group received a weekly PRO monitoring on their personal smartphone, and in case of deteriorating scores that were calculated comparing individual scores 1 and 4 weeks prior, an alert was automatically sent to the patient's treating center. The center's response then was to answer and contact the patients in the next 48 hours and document whatever action has been taken. Patients in the control group received standard of care and also a PRO survey through their own smartphone every 3 months. Patients were randomized in a one-to-one fashion, and we were able to include 463 patients in the intervention group and 461 into the control group. Because 7, respectively 8 patients never answered any of the questionnaires, they had to be excluded from the primary analysis. So for the baseline assessment, we had 456 patients in the intervention group and 453 in the control group. At the time of the primary outcome, at 6 months, there were 399 patients actively participating in the intervention arm and 362 in the control arm. At the time point of the secondary analysis at 12 months, there were 278 patients in the intervention arm who were active in the study and 243 in the control arm. The primary endpoint of the ProB trial is the level of fatigue at 6 months in the intervention group compared to the control group. Secondary outcomes included survival after 12 months in the intervention versus the control group, survival in patients with triple-negative disease and visceral metastasis, as well as health economic evaluation, among other things. Clinical baselines were fairly balanced in both groups. What stands out is the high number of patients with multiple metastatic location and/or brain metastasis in both groups, with over 55%. The other notable point is also the high number of patients receiving chemotherapy while participating in the ProB trial, also with close to 50% in both groups. We had a fairly high number response rate in the intervention and control arm, with 92% in the intervention at 3 months, 89% at 9 months, and 90% at 12 months. In the control arm, we had a 77% response rate at 3 months, 70% at 9 months, and 72% at 12 months. Median follow-up was 64 weeks for the intervention arm and 52 for the control arm. As you can see here on the right and the lower blue line, we had an average alert rate across the whole intervention group per week of about 12 alerts. This responded to you see in the green line above, the response rate by the center that was about 92% across the study. This shows the primary endpoint of the ProB trial, the reduction of fatigue at 6 months in the intervention group compared to the control group, light green being the intervention group, dark blue the control group. And we not only have a significant reduction of fatigue in the intervention group at 6 months, but we also have a prolonged effect showing the same at 9 and 12 months. Looking at the forest plots, it becomes clear that this effect is significant for all groups and more pronounced so for patients with visceral metastasis and with hormone receptor negative disease. But we not only have a statistically significant reduction in fatigue, we also have a clinically meaningful reduction of fatigue with an MCID of minus 3.3 in the T-score metric, which is an equivalent of 8 points in the EORTC QLQC30 metric, which is considered clinically meaningful by the EORTC working group. In addition to having a primary positive endpoint with a significant clinical and statistical reduction in fatigue, we were also able to show a survival benefit in the ProB trial with a reduction of mortality of 29% in the intervention group compared to the control group. This effect was even more pronounced in patients with visceral metastasis with a hazard ratio of 0.51, but because of the smaller sample size, it did not reach statistical significance. Something similar was seen in patients with triple-negative disease with an adjusted hazard ratio of 0.61, and the hazard ratio for a patient with hormone receptor-positive disease was 0.71. In light of these findings, we took a closer look at the symptom burden and alert rate of those patients who unfortunately died while being on the ProB study. And a very clear picture emerged. We see that starting 3 to 6 months before death, the alert rate steadily increases up to 50% in the last month before death. This stands in contrast to the steady alert rate seen here in green for those patients who were still alive at the end of the ProB study. This picture also is seen in the symptom burden those patients who died had to go through. And we see here with the darker colors being closer to death, you see that there is a steady increase in the symptom burden in those patients who are dying, and that there is a higher rate of symptoms in the control group compared to the intervention group. This also stands into clear contrast compared to those patients who were still alive at the end of the study, and their symptom burden shown here in green. This brings me to the conclusion. In the multicentric ProB trial, an alert-based PRO monitoring resulted in a statistically and clinically meaningful reduction in fatigue across all subgroups. Alert-based PRO monitoring led to a 29% reduction in mortality in the intervention group compared to the control group. And implementing alert-based PRO monitoring in a routine care setting across a wide range of providers and different settings can be successfully done. With this, I want to finish and heartfully thank the patients and their families who supported the ProB study and who provided us with all those notes that you have seen here in the feedback. I also want to thank the partners in the ProB consortium and the organizers of this conference. Thank you very much.
If there are questions, please go to a microphone. Is there a question at microphone 5?
Ann Partridge, Dana-Farber, very nice presentation. Can you clarify for us how you assess the symptoms in the control group? And you acknowledged alerts in the control group, but if they weren't answering PROs, how did you assess that?
Yes, so that I might have misspoken. So there were no alerts. First, there were no alerts in the control group. So the patients in the control group really only received standard of care and a questionnaire every 3 months on their phone, but no alert. And we assessed symptoms by these by the symptoms reported every 3 months. So that's also seen at the wider bars. So that's why we have less data, of course, for those patients compared to those in the intervention group.
Thank you.
Microphone 2, Dr. Kropp.
Hi, Ian Kropp, Yale. Wonderful presentation and trial. Do you have any data on what the interventions that were done by the clinics when they received the alerts? Do you have a sense of was chemotherapy discontinued, dose reduced, anything to perhaps account for the survival benefit, which is so impressive?
Yes, so excellent question. Of course, this is what we are also curious to find out. We required the centers to report in a standardized formula what actions were taken. For example, if they were a patient was called to in-house or to the emergency room, if there was a change in medication and so forth. At this point, since the study stopped in September of this year, we have not finalized the analysis, but this will be reported hopefully soon.
Thank you.
Microphone 6.
Vogel, New York, very interesting study. I wondered what
was done after the report came in that would affect fatigue, and why you thought it would happen since that was your primary endpoint. Did you think the PRO led to psychological, emotional support, and that's why the patient complained of less fatigue? Or was there suddenly the administration of erythropoietin or sympathetic amines to energize the patients?
Yes, so also an excellent question, thank you. So we did a lot of soul searching and the literature, and, spent a lot of time on defining the primary endpoint of the study. And since fatigue is the one of the most common reported symptoms in advanced breast cancer patients, this is what we picked. To answer your question, I think personally, and this goes a little bit in the direction of the question that was just asked, at this moment we think it's a mixture of things. We see that there are trends in changes in support in therapy changes, and that symptom detection was earlier. But I also think that there is a psychological support system. This is what patient reported after the study, that they felt a sense of security because they knew if there's a deterioration that they would be contacted.
I guess it's good to tell the patient, I'm sorry you're tired.
Thank you. Thank you for the excellent presentation. I'd now like to call Dr. Gabrielle Rocque to give the discussion on this important study from the University of Alabama at Birmingham.
Good morning. I am delighted to be here today and grateful to the conference organizers for the opportunity to discuss this excellent presentation by Dr. Karsten and really to put Pro-B into contemporary context. Here are my disclosures. So I think it's helpful to always start with what is the primary question that's being asked by the research, and take a moment to think about what was selected for the primary outcome, which in this case is fatigue. These investigators are answering, does a remote symptom monitoring program using electronic patient-reported outcomes improve fatigue in patients with metastatic breast cancer? And this is a symptom and a problem that is experienced by so many women with metastatic breast cancer, regardless of subtype and what types of therapies that they're on, and is an incredibly patient-centric thing to be focusing on for the primary outcome. And it's important to note, too, that this is a metastatic breast cancer population that, in fact, is relatively sick. So in this group, they had 70% of patients with visceral disease, and approximately half were on chemotherapy. This is different than some of the patients that may be coming in for their very first treatment. And that's exemplified in the reality that on this study, 18% of people died within the 2-year study period. So this population is somewhat enriched for patients that have a higher symptom burden and potentially some who may be approaching end of life. So they did see a significant reduction in fatigue at the end of fatigue at 6 months, which was their primary outcome. And I think, again, it's important to note that the greatest differences they saw were in those patients that had visceral disease, brain or multiple sites of disease, more so than those who might have had a more indolent course with a bone and lymph node only disease. And also, it's important to think about where are we seeing the greatest symptoms? Where is there huge opportunities for us to be much more responsive to patient needs? And as presented by Dr. Karsten, in the last month of life, approximately half of patients were having an alert, something that was requiring management by the clinical team, compared to a 10 to 15% rate for those patients not at the end of life. Similarly, in terms of the survival differences, those are also greatest in the patients that had a higher mortality. They're including those with triple-negative disease and visceral disease. So if you think about the key takeaways first from this study, remote symptom monitoring using electronic patient-reported outcomes is effective in women with metastatic breast cancer, as shown today. And the greatest impact is in populations traditionally considered to have a high morbidity and mortality. There are certainly some limitations to this study in terms of the fact that this is a heterogeneous group of patients. It's a little bit hard to interpret which patients might have benefited the most from this intervention. This also requires a smartphone app, so may have more limited applicability in patients with low digital health literacy. And that is reflected in the demographics that the majority of the patients in this study had a medium or higher education level. So I think it's important to think about this study in the context of the greater body of work around electronic patient-reported outcomes and specifically remote symptom monitoring. It's been 9 years since the original publication by Dr. Ethan Bash and colleagues that looked at remote symptom monitoring using ePROs within an advanced cancer population, including women with metastatic breast cancer, demonstrating improvement in quality of life as their primary outcome, as well as symptom control, time on chemotherapy, and survival. In 2017, Dr. Mooney and colleagues showed similar benefits in terms of symptom management. In 2020, a Canadian study led by Dr. Barbera and colleagues in a retrospective analysis found improvements in emergency room visits, hospitalizations, as well as survival. In 2022, in a study focused more exclusively on patients receiving oral treatments, they found improvement in chemotherapy dosing, that patients were able to get a higher dose level when their symptoms were managed better, improvements in hospitalizations, grade 3 symptoms, as well as patient satisfaction. More recently, in 2022, the PROTECT trial was published, again focused on quality of life across cancer types. This was a 52-site randomized controlled or cluster randomized trial that also found improvements in physical function and symptoms. And all of this previous work is pan-cancer type and doesn't focus specifically on a metastatic breast cancer population. And that's really where this current study is adding just another level to the data. That in 2024, we can say in a focused population, we see improvements in fatigue and survival as well. So I think this really begs the question, why are we not using remote symptom monitoring for all patients, with metastatic breast cancer that are on active treatment? We now have 9 years of data across multiple different countries as well to say that this could be done. And I think there is some clear movement in this direction from a policy standpoint. Many of you may not be familiar with the Center for Medicare and Medicaid Innovation's Enhancing Oncology model, which is a new payment model that is actually requiring the use of electronic patient-reported outcomes for participants. And there's a little bit of information on the left about the model and a sheet that sort of explains from Medicare's point of view why this is important for patients on the right. And this model is being run across locations across the US. And so all of these practices across the next few years will be looking to implement the type of intervention that has been shown here today to be effective. And there's fortunately actually a fair amount of good data also that this can be done. So some of this work has been led by Dr. Mike Hassett with the eSIM experience, and this was their early publication on their mass rollout from 2019 through 2021. You can see what a dashboard might look like in the figure here. This was administered across 4 sites, and they engaged over 3,000 patients and captured over 26,000 symptoms in this early work, which has continued and is ongoing and growing at that center and their participating centers. Another implementation, the Texas Two-Step by Deborah Patt, conducted in the height of the pandemic from July through December of 2020 across 210 sites, engaging more than 4,000 patients, more than 16,000 symptom surveys, also showed that this was very reasonable and feasible to be done in community practices. And I think they also showed something really helpful for those of us who are thinking about how this is applied in real-world settings in their way that they're collecting this information, as shown by the figure in green. The vast majority of people are responding via their phones, how they communicate with their friends and family, allowing them an opportunity to using text messaging or SMS, as shown by the dark green, to engage with their clinical teams. And then on the figure B, really seeing that that's the way that the people were able to participate the best was through the text messaging, although they did have email and other ability to use clinic-collected data as well. And in a small subset analysis, they found improved healthcare utilization and lower cost of care amongst their Medicare patients specifically. And this is also not just a US thing, this is being done around the world. So in France and Belgium, this group published from November 2021 through August of 2023 in 33 cancer centers across these two countries with 168 providers, over 3,000 patients, finding that 90% of patients report a positive impact on care. And that has been consistently shown across all of these studies, the patient experience and benefit from using these types of systems. And finally, our own experience at the University of Alabama at Birmingham and the University of South Alabama. We recently had the opportunity to present on data from May 2021 through 2024, where we engaged almost 1,400 patients who are completing surveys. And when compared to historical control, we see about a 20% reduction in hospitalization at 3 months and ICU admissions at 3 months, going from 28% in the control group to 22% in those patients receiving and participating in remote symptom monitoring. So as you think about where do you go from here if you don't have this in your practice, there actually is a lot of available data on how to think about implementation in clinical practice. So many of the investigators that I've mentioned previously, as well as myself, participated in a paper about what are the tenets, what should you be thinking about when you're implementing patient-reported outcomes for remote symptom monitoring during cancer treatments. And the Proteus website shown here on the right, led by Dr. Claire Schneider, is a really wonderful resource for patient-reported outcomes, both within clinical trials as well as in standard of care in oncology, as well as across all different types of medical disciplines, and has been a really wonderful resource for individuals that are interested in implementation. So I'd also like to point out that there is a PCORI-funded project that I am involved with Dr. Ethan Bash called the OncoPro Consortium, in which we are working together with practices across the country and across the world to try to implement patient-reported outcomes in conjunction with key groups like the American Society for Clinical Oncology, some of the major electronic medical record vendors, and ePro vendors, and are very much interested in supporting practices who are excited and ready to roll this out. So I think there's really no doubt in my mind that the data are strong. They cross many cancer types, including breast cancer, that remote symptom monitoring for using electronic patient-reported outcomes benefits patients, and implementation at scale is feasible and possible. And this is something that we really should be thinking about. How are we going to do this in our practice sooner than the next 9 years, since we've already been waiting for quite a long time? And I think it's also time to think about what are the next generation of questions that we should be asking using ePros. Is there an opportunity for us to be customizing our tools, potentially using AI to guide who should get what surveys and when? I often wonder, and this presentation today by Dr. Karsten makes me think about what is the role of ePros for patients with different patient profiles? If you have a lower symptom burden, potentially you're a patient just starting therapy with a CDK4/6 inhibitor for first-line ER-positive disease, should that look different than somebody who is on, a more aggressive chemotherapy regimen or potentially approaching end of life? I also wonder, how long should we continue surveys? Are we really going to do a weekly survey of patients if they're on the same treatment for the next 5 years? How can we customize and make this responsive to the needs of patients in the best possible way? And are there differences in the questions we should ask in survivorship or end of life? I think there are so many opportunities to get a better understanding of what our patients experience day to day through their cancer journey on these medications. I also think there's some real opportunities for us to think about how do we identify potentially rare but serious complications through mass collection of ePros and looking at the events that are occurring, and could that replace some of our current post-monitoring approaches that maybe are less patient-centric? And finally, where are the opportunities to include EPROs within clinical trials as more than just outcomes, but as something that we can manage and really improve those symptoms? Could that improve side effect profiles and allow us to keep patients on their medications longer? I think there is a lot of data to suggest that that is the case in standard of care, and it's time for us to be thinking about some of these new questions. So with that, I'd like to thank, again, the audience and Dr. Karsten for her excellent presentation, as well as all of my colleagues who have worked in this space for the many years in the past and hopefully in the future to really implement and make sure that this becomes the standard of care for patients with metastatic breast cancer. Thank you.
Thank you so much, Dr. Rocque. I'd now like to invite our next presenter, Dr. Matteo Lambertini of the University of Genoa. He will be presenting association between risk-reducing surgeries and survival in young BRCA carriers with breast cancer, results from an international cohort study. Welcome, Dr. Lambertini.
Dear colleagues, it's a great honor on behalf of my co-authors to present the results of our international cohort study investigating risk-reducing surgery in young BRCA carriers with prior history of breast cancer. And I'm very grateful to the San Antonio Breast Cancer Symposium Scientific Committee for selecting our abstract for General Session 1. Cancer risk management strategies, including bilateral risk-reducing mastectomy and risk-reducing salpingo-forectomy, are widely recommended in BRCA healthy carriers. However, in BRCA carriers with prior history of breast cancer, additional challenges should be considered in the counseling regarding risk-reducing surgeries, especially among young patients. The risk of relapse of their primary breast cancer should be balanced with the risk of developing a second primary malignancy. Although reducing breast and/or ovarian cancer risk, while risk-reducing salpingo-forectomy has shown to improve overall survival in BRCA carriers of all ages with prior history of breast cancer, the impact of risk-reducing mastectomy reducing mortality remains controversial. And specifically when we counsel young women, we should keep in mind that these surgical interventions have an impact on reproductive plans and quality of life. To date, no prior studies focus specifically on the role of risk-reducing surgeries among BRCA carriers with prior history of breast cancer at a young age, defined as 40 years or less at diagnosis. The BRCA-BCY collaboration is an international multi-center hospital-based retrospective cohort study that included patients with stage 1 to 3 invasive breast cancer that was diagnosed between January 2000 and December 2020. All the patients were young at the time of breast cancer diagnosis, so 40 years or less, and all the patients were known to carry a germline likely pathogenic or pathogenic variants in the BRCA genes. We excluded patients with stage 4 de novo breast cancer, those with history of ovarian cancer or other malignancies without prior history of breast cancer, those with BRCA variant of unknown significance, and BRCA healthy carriers. For this specific analysis, we also excluded patients with no information on uptake or timing of risk-reducing surgeries or their uptake before diagnosis of breast cancer. The main objective of this analysis was to determine the association between risk-reducing surgery and survival, with overall survival as the primary endpoint, disease-free survival and breast cancer-free interval as secondary endpoints. All these endpoints were defined according to the STEEP criteria. Predefined subgroup analysis of overall survival were performed according to the age at the time of breast cancer diagnosis, the specific BRCA gene, the tumor subtype, primary tumor size, primary nodal status, chemotherapy treatment, timing of BRCA testing, and income. Before going into the details of the statistical analysis, I wanted to emphasize that we were fully aware of the complexity of this analysis and the potential biases with this type of study and this type of analysis. So a predefined statistical analysis plan was prepared by 4 experienced statisticians together with the study team, and several efforts have been made to try to control for the potential biases. Specifically, to explore the association between risk-reducing surgeries and survival outcomes, Cox models were used with risk-reducing surgeries included as time-dependent covariates. Adjusted models included as stratification factors year at breast cancer diagnosis, region, and nodal status, so those factors that were significantly associated with overall survival at the univariate analysis with a p-value of less than 0.20. Considering that the decision to undergo a risk-reducing surgery may be influenced by the development of a distal recurrence or a second primary malignancy, overall survival models were also adjusted by the development of distal recurrences and second primary malignancies as time-dependent covariates. Since the Kaplan-Meier method does not account for time-dependent covariates, in order to plot survival curves, the Simon and Makuch method was used so that we could take into account the change in an individual covariate status over time. Moreover, to account for the potential lead time bias, so taking into account the different timing of the BRCA testing throughout the cancer care trajectory of the included patient, two sensitivity analyses were conducted. The first by including only patients tested for BRCA before or within 6 months after breast cancer diagnosis, and second by performing a survival model where observation time were left truncated at the time of BRCA testing. And finally, to account for the potential guaranteed time bias, so to take into account the possibility that patients with better prognosis were more likely to be counseled to undergo these surgical procedures, a 3-year landmark analysis was conducted by including only patients alive and observed at 3 years after breast cancer diagnosis. From 109 centers in 33 countries and 5 continents, 6,238 patients were registered, and after applying the inclusion-exclusion criteria for this specific analysis, 5,290 patients were included, all were young BRCA carriers with diagnosis of breast cancer. And subsequently, 2,910 patients underwent risk-reducing mastectomy, and 2,782 underwent risk-reducing salpingo-oophorectomy. Among these patients, 1,804 underwent both risk-reducing mastectomy and risk-reducing salpingo-oophorectomy. Median follow-up in the overall cohort was 8.2 years. In terms of patient and treatment characteristics in the overall cohort, the majority of patients were treated in high-income country, 86.7%. Median age of the patient was 35 years at the time of breast cancer diagnosis. Around half of the patients, 48.8%, were tested for BRCA before or within 6 months after breast cancer diagnosis. 2/3 of the patients, 63.5%, were BRCA1 carriers. Half of the patients, 51.2%, had no negative disease. In terms of breast cancer subtypes, 35.9% had hormone receptor-positive HER2-negative disease, and 49.1% had triple-negative breast cancer. The majority of the patients, 91.8%, received chemotherapy in the adjuvant or neoadjuvant setting. Starting with the first analysis on risk-reducing mastectomy, 2,910 patients, so 55% of the total cohort, underwent this risk-reducing surgery at the median age of 36.6 years. The median time from diagnosis of breast cancer to risk-reducing mastectomy was 0.8 years, and the median follow-up after risk-reducing mastectomy was 5.1 years. Risk-reducing mastectomy was associated with a significant improvement in overall survival with an adjusted hazard ratio of 0.65. The sensitivity analysis showed consistent results with an adjusted hazard ratio ranging between 0.54 and 0.61 in the 3 different models. At the subgroup analysis, no significant interaction was observed between risk-reducing mastectomy and the analyzed subgroups, meaning that the risk-reducing mastectomy was associated with significant improved overall survival in all the analyzed subgroups. Risk-reducing mastectomy was also associated with a significant improvement in disease-free survival and breast cancer-free interval with an adjusted hazard ratio of 0.58 and 0.55 respectively. As expected, patients that underwent risk-reducing mastectomy had a significantly reduced risk of developing a second primary breast cancer as first disease-free survival event. Moving now to risk-reducing salpingo-oophorectomy, 2,782 patients, so 52.6% of the total cohort, underwent this surgical procedure at a median age of 39.7 years. The median time from diagnosis of breast cancer to risk-reducing salpingo-oophorectomy was 3 years, and the median follow-up after risk-reducing salpingo-oophorectomy was 4.9 years. Risk-reducing salpingo-oophorectomy was associated with a significant improvement in overall survival with an adjusted hazard ratio of 0.58. Again, the sensitivity analysis show consistent results with an adjusted hazard ratio ranging between 0.47 and 0.70. Only in the first model, including patients tested for BRCA before or within 6 months after diagnosis, the upper limit of the 95% confidence interval crossed the unit, being 1.01. At the subgroup analysis, a significant interaction was observed between risk-reducing salpingo-oophorectomy and the specific BRCA gene and the tumor subtype. The benefit of risk-reducing salpingo-oophorectomy was greater in BRCA1 carrier as compared to BRCA2 carrier, and a possible explanation is the lower risk of ovarian cancer in BRCA2 carrier, the very young age of the patient included in our study, and the relatively short follow-up. For the tumor subtype, a greater benefit for risk-reducing salpingo-oophorectomy was observed for patients with triple-negative disease as compared to those with hormone receptor-positive HER2-negative disease, and the possible explanation is related to the different distribution of breast cancer subtypes in BRCA1 as compared to BRCA2 carriers. Risk-reducing salpingo-oophorectomy was also associated with a significant improvement in both disease-free survival and breast cancer-free interval, with an adjusted hazard ratio of 0.68 and 0.65 respectively. As expected, patients that underwent risk-reducing salpingo-oophorectomy has a significantly reduced risk of developing a second primary ovarian cancer and a second primary breast cancer as first disease-free survival event. Finally, we look into the 1,804 patients that underwent both risk-reducing mastectomy and risk-reducing salpingo-oophorectomy, so 34.1% of the total cohort. And we wanted to explore whether the effect of one surgery was different in patients undergoing one and not the other surgical procedure. And to do that, survival models with both risk-reducing surgeries and their interaction term were performed. No statistically significant interaction was observed between risk-reducing mastectomy and risk-reducing salpingo-oophorectomy on overall survival, suggesting that the effect of this surgical procedure were independent. On the contrary, significant interaction was observed in disease-free survival and breast cancer-free interval, with the effect of risk-reducing salpingo-oophorectomy on these outcomes that was more pronounced in patients who underwent also risk-reducing mastectomy. And to interpret these results, we should keep in mind that it is a young patient population with a high risk of developing a second primary breast cancer, which count as an event for the DFS and breast cancer-free interval definition. In conclusion, this global study, including 5,290 young BRCA carriers from 109 centers worldwide, provides evidence on the association between risk-reducing surgeries and survival outcomes among young BRCA carriers with a prior history of breast cancer. Our results show that undergoing this surgical procedure was associated with a significant improvement in overall survival, disease-free survival, and breast cancer-free interval in this special clinical setting. And I want to stress is a setting of patients that had their first breast cancer diagnosis below the age of 40 years. The favorable impact of risk-reducing mastectomy on overall survival was observed irrespective of the specific BRCA gene, while the beneficial effect of risk-reducing salpingo-oophorectomy was more pronounced in BRCA1 carriers. The effect of risk-reducing mastectomy and risk-reducing salpingo-oophorectomy on overall survival were independent. On the contrary, the effect of risk-reducing salpingo-oophorectomy on disease-free survival and breast cancer-free interval was more pronounced among patients who underwent also risk-reducing mastectomy. Our final conclusion is that we hope these findings may help to improve the counseling on risk management strategies for BRCA carriers with young onset breast cancer, but they should not be used to counsel BRCA healthy carriers nor BRCA carriers with diagnosis of breast cancer at an older age. And in these slides, I wish to thank all the people and entities listed on this slide that made this academic effort possible, and thank you very much all for your attention.
Thank you. We have time for 1 or 2 questions. Microphone 3, please.
Congratulations. My name is Guilherme Novita from Brazil. Just one question. Do you think that the socioeconomic status may have interference in our results because you divide in high-income countries and poor-income countries, but we know that we have differences between the population in these countries. And what about the other death causes? Should be a new marker to avoid this bias? What do you think about that?
Yeah, thank you very much for your question. Indeed, this was one of the subgroups that we have investigated. So we have looked into potential differences according to the income. And for both analyses, for risk-reducing mastectomy as well as risk-reducing salpingo-forectomy, there was no interaction. So apparently this did not influence the results. But actually what we have observed is that the number of patients undergoing these risk-reducing surgeries in different countries based on the income was different. In high-income countries, there was a larger uptake of these risk-reducing surgeries as compared to the other countries.
Microphone 6.
Ellen Warner, Toronto. Thank you for the wonderful study. Do you have any data on the imaging surveillance that the women who didn't undergo risk-reducing mastectomy received, specifically whether they had access to MRI or not?
Yeah, thank you very much for the question, very important, but unfortunately this was not collected as part of the study. However, we presented at ASCO a few months ago the data on those patients that were known to be BRCA carriers before diagnosis of breast cancer, so those patients that were likely to undergo like imaging procedure before diagnosis of breast cancer, and indeed there was a huge impact in terms of tumor downstaging and also a positive effect on survival outcomes. But in this specific case, so after breast cancer, in those patients without risk-reducing mastectomy, we did not collect this data.
Thank you.
Thank you, Dr. Lambertini. We're going to move on. Congratulations on your work. Our next abstract will be presented by Dr. Judy Garber of the Dana-Farber Cancer Institute. She'll present long-term follow-up of Olympia, a phase 3 trial of adjuvant olaparib following chemotherapy in patients with germline BRCA mutations and high-risk HER2-negative breast cancer. Welcome, Dr. Garber.
Thank you. Dr. Thomas, Dr. Momrani, and colleagues, on behalf of the Olympia investigators and research team, I thank the organizers for the opportunity to present the results of the pre-specified analyses of invasive disease-free survival, distant disease-free survival, and overall survival 10 years from first patient in the Olympia trial of adjuvant olaparib in germline BRCA1 and 2 mutation-associated breast cancer. Hopefully. This is not advancing. Do you have any suggestion? Can I try it here? There you go. Okay, thank you, sorry. These are my disclosures. But now we're not going to advance here either. There we go. This diagram depicts the partnership for Olympia between AstraZeneca Merck and the U.S. National Cancer Institute with academic clinical trialist organizations, the Breast International Group internationally, and the NRG as lead U.S. group with the data and analytic teams at Frontier Science. The rationale for Olympia, just to remind you, is based on the observation that the inhibition and trapping of PARP1 on DNA by a PARP inhibitor, here olaparib, leads to synthetic lethality with loss of function of either BRCA1 or BRCA2 proteins and the resultant loss in the tumor of homologous recombination. Because BRCA1-associated breast cancers are largely triple negative, while BRCA2-associated tumors are most often hormone receptor positive, both were included in Olympia. This trial examined the PARP inhibitor olaparib as adjuvant therapy in patients with germline BRCA1 or 2 pathogenic variants after completion of multimodality treatment for high-risk HER2-negative breast cancer. Olaparib significantly improved the invasive disease-free and distant disease-free survivals at the first pre-specified interim analysis and overall survival at the second pre-specified interim analysis. So we now report the third pre-specified analysis at 10 years from first patient in. So median follow-up is now 6.1 years. It's an additional 2.6 years from the previous assessment. So as per the study schema, Olympia was a 1-to-1 randomization to the PARP inhibitor olaparib or placebo in 1,836 carriers of BRCA1 and or BRCA2 germline pathogenic variants with high-risk early breast cancer following then standard multimodality therapy, including neo or adjuvant chemotherapy, surgery, radiation, and when indicated, hormonal therapy. The primary endpoint was invasive disease-free survival with several secondary endpoints. The two arms of Olympia were balanced for age, and you can see that the cohort was quite young, and for BRCA1 versus BRCA2 pathogenic variants with about 70% BRCA1, and menopausal status with about 60% premenopausal, nearly 75% underwent treatment mastectomy. Hormone receptor status was also balanced with 80% triple negative as noted, and similar distributions of chemotherapy equally divided between neoadjuvant and adjuvant treatment. Endocrine therapy was also balanced between the study arms. So this third pre-planned analysis was conducted with this median follow-up of 6.1 years and maximum follow-up 9.6 years. Significant improvement had been demonstrated previously for IDFS, DDFS in the first analysis and OS in the second. So this third analysis, therefore, does not use additional alpha, rather it's descriptive. So the updated data for all first IDFS events, shown in bold, demonstrates that distant, regional, and local recurrences remain more frequent in the placebo arm. This convention of showing the data from the second interim analysis in italics will be maintained on subsequent slides. As demonstrated in the Kaplan-Meier curves, at 6 years median follow-up, the absolute difference in IDFS for olaparib and placebo is now 9.4%, with hazard ratio 0.65 and confidence interval excluding 1. The forest plot demonstrates that the effects are consistent across all subgroups, given that the stratified hazard ratios for all subgroups are less than 1, and their confidence intervals include the estimated population hazard ratio shown in the solid red line. Olaparib reduced the risk of recurrence of IDFS in both the triple-negative and hormone receptor-positive groups. At this updated analysis, the magnitude of benefit remains similar, with more than 30% reduction in both groups. Note that currently, the number of patients followed long-term in the hormone receptor-positive group is very small. The results for the triple-negative group are more stable at this analysis. With further follow-up, the benefit of olaparib for DDFS is also maintained, now with an absolute difference of 7.8 years and a hazard ratio of 0.65 and confidence interval again excluding 1. And again, the DDFS is consistent in all subgroups. With additional follow-up, most deaths in Olympia continue to be the result of breast cancer recurrence, with more in the placebo arm. The absolute difference in overall survival at 6 years median follow-up is now 4.4%, favoring olaparib, with the hazard ratio now 0.72 and confidence interval again excludes 1. And again, the benefit for olaparib for overall survival is consistent in all subgroups, with confidence intervals for all hazard ratios crossing the overall hazard ratio estimate. Here are the adverse events of special interest, which also continue to be greater in the placebo arm. With further follow-up, the incidence of MDS-AML events in particular remains low, with 4 in the olaparib arm and 6 in the placebo arm. And there are fewer malignancies, second primary malignancies, in the olaparib group. So we certainly considered the possibility that olaparib would reduce the risk of the development of additional BRCA-related tumors, cancers, and that the issue in adjusting in this analysis, as we've just heard really, for risk-reducing surgeries is not just whether the surgeries take place, but when. And in this table, you'll see that there are fewer cancers in the olaparib arm, but and Clearly, we have more work to do. And the competing risk analyses, which were done to account for the risk-reducing surgeries with time, had confidence intervals so large we elected not to present them. These are pregnancy data, which are exploratory, but are remarkably similar in the two arms and may provide some reassurance given the young age of trial participants overall. So in conclusion, at 6.1 years of follow-up, 12 months of olaparib after completion of neo and adjuvant chemotherapy continues to demonstrate clinically meaningful improvements in all endpoints in patients with pathogenic BRCA1 and or 2 variants who were eligible for participation in this trial. The benefits of olaparib were seen across all subgroups, including, importantly, patients with hormone receptor positive disease. Fewer new primary cancers were observed in the olaparib arm. There were no new safety signals observed with the additional follow-up, particularly no increased risk of AML and MDS. These data continue to support the use of adjuvant olaparib as standard of care for patients with germline BRCA pathogenic variants and high-risk HER2-negative breast cancer. And the data emphasize the importance of considering germline testing for treatment planning. And blinded follow-up for the final planned analysis will continue until June 2029. We also have many individuals to thank and many groups, and I would particularly like to thank both the Frontier Science team and Dr. Andrew Tutt for assistance with this presentation. And we do dedicate these results to our co-PI, Dr. Bella Kaufman, who was instrumental in Olympia's design and conduct and died shortly before the primary analysis was published.
Thank you so much, Dr. Garber. Wonderful presentation. Do we have a few moments for questions? Great. Microphone 4, please.
Hi, Dan Hayes, University of Michigan. Very nicely done, Dr. Garber. Can you tell us, are there any planned or ongoing chemo prevention trials with this drug? I know the safety issues in Olympia were very important before those would get started, and it looks like it's a pretty safe drug.
Thank you for the question, Dan. Yes, in fact, although I don't think anyone would want to give continuous olaparib dosing for chemo prevention, there is a question of whether one could give intermittent dosing. Maybe you can remove those cells that have begun to transform if this were done periodically for short exposures. And this kind of model of chemoprevention is actually in development by our group, led right now by Dr. Susan Domchek, and we'll see whether we are doing this as a multi-center study over the next several months. So thanks for your question. I hope so.
Microphone 4, please.
Brugo at UCSF. Beautiful presentation, beautiful results, beautiful tribute. So a question you can't completely answer. What do you do about people with PALB2 mutations? We've seen the really beautiful data in the metastatic setting, looking fabulous. Shouldn't we be giving olaparib to patients with high-risk PALB2-associated breast cancer?
Hope. I absolutely think we should. I think the challenge that really the FDA and other regulatory agencies have to take on is how much data it takes for them to broaden an indication for a specific gene not part of an individual trial. I'm sure we won't see an Olympia for PALB2, but there's hardly any reason to believe that this would not be important, and I think many people are trying to negotiate with insurers to get this covered based on the data from Dr. Tung's study that you refer to.
Our guidelines can play a role.
I certainly think this should be incorporated myself. That's me.
Great, thanks, Dr. Garber. I'm going to take one question from online. With consistent and long-term benefits of adjuvant olaparib in BRCA-mutated disease, please share your thoughts on how and if pembro should be added to olaparib or given after.
So, of course, you're right that the trial was conducted before immunotherapy became standard of care, before CHEK2 inhibitors. There's very little data on combinations showing particular effectiveness. I think most people are giving immunotherapy before olaparib, and as here, you would give it after surgery. Clearly, though, the data show that giving it early is important, so I think you would not hesitate. And there actually are no data with particularly adverse effects of combining the two, so many people also do that.
We'll close out the session with one last question, microphone 5.
An increasing number of triple-negative breast cancer patients receive carboplatin or platin class of drugs, either in the adjuvant setting or the neoadjuvant setting. You think olaparib will hold its worth or its impact even in those patients who have been exposed to carboplatin or platin class of drugs?
So I would say that according to our data, where there is a subgroup who was exposed to platinum, that we have no reason to say at this time that they did not benefit. They seem to have the same benefit as other subgroups that were analyzed. More follow-up may change that, but I'm not sure why it should. We have maintained that consistent benefit through now 3 interim analyses.
Thank you so much, Dr. Garber.
This concludes the first general session. Enjoy the rest of the meeting. Thank you.